Looks like we're up and running. Perfect. Okay. Sorry, I'm just making sure things are still in order. Yo, Lobster, how's it going? Good to have you here. Okay. I should really rename this thing. Working, sure. Okay. For some reason, I feel like I forgot to do something before I started the stream, but I don't know what that thing is, so... Hey, Syntax here. Okay. So for today, for my kind of... well, actually, well, not for the entire stream, but at least to start off the stream, I had this proof on my mind that I've been wanting to do since I read the question last night. And oh my god, what the heck am I saying? And I kind of like I'm gonna comment on the question in a second, but it was just kind of a fun question, and I kind of felt the urge to LaTeX it up and type it up nicely. So I have a book that I've been reading from, and I'm gonna type down the thing here. I didn't realize that we're given that these sequences are bounded. A sub n and b sub n slash begin equation slash lim inf n slash 2 slash inf t a sub n plus slash lim inf n slash 2 slash inf t b sub n is less than or equal to. It's going to be a bit of typing to get this stuff set up, but once we get going, we will be going. Plus b sub n less than or equal to lu slash lim sup n slash 2 slash inf t. Wait, am I even copying this down right? Yes, I am. Okay. A sub n plus b sub n. Wait, no, parentheses, not brackets, braces. Slash leq slash lim sup n slash 2 slash inf t a sub n plus slash lim sup n slash 2 slash inf t. This is I'm also doing this because I feel like it'd be a good like LaTeX exercise also. So let's see how this looks already. Can we make this not tiny? For any bounded sequence, do I need to escape the curly braces? Oh yeah, how do you do a subscript? Do you need oh shoot. I was does that That part works now. Dude, please don't try to guess my dollar signs. No, stop. Thank you. Oh my god. Are you happy now? Okay. Why? Oh shoot. Because I need an underscore, I think. Okay, that looks a bit better now. Okay. Is that the entire question, or is there more? Oh, I lost my page. That's great. Here's my page. That's the entire question. Okay, good. I do want to copy down the relevant definitions in the next section, though. How do you do like a bullet list? LaTeX bullet list. Itemize. Slash begin itemize and slash item. That's not it. Okay. Slash begin itemize. How do you do bold? LaTeX bold. Text BF? That's so much typing. Text BF. Limit superior. Text BF. Upper limit. The largest of all limit points for a sequence. I guess we should define limit point too. Lower limit. Smallest limit points for a sequence or of a sequence? Of a sequence, I'm gonna say. Limit points, where are you? The way the book phrased it makes it kind of hard to translate it into this format. A point with a convergent subsequence, I guess? A point with a corresponding convergent subsequence, I guess I'm gonna say. How does this look? Limit point of a sequence. Sole limit points of a sequence, the small sole limit points of a sequence. Denoted by we're gonna need dollar signs. Slash lim sup n/2/empty of a sub n. Okay. Can I zoom this window in on the right? Yes. Good. Okay, now it's much easier to read on stream, I'm sure. Hey, AS Gaming Bros. How's it going? If I do that, oh. Okay, cool. So down here is the proof that I wrote out on my phone last night. At least part of the proof. I started by proving the right side of this inequality. I was doing like in bed right before I was going to go to sleep, so I'm not sure how much sense it's going to make. It's going good for me. I'm just for the reason I felt the urge today to type out a proof kind of nicely for a question that I found interesting. So that's what I'm doing for now until someone pops into the math question. So that'll also be a nice opportunity to get a bit more comfortable with LaTeX here. So do we need this equation one, or what? Does the one go away there? No, the one is still there. Okay. Actually, no, that's 2. Such right. Okay. Hey Phobos, let delta exist and let epsilon be tiny. Make a lot of proofs simpler. Proof. I didn't put the question marks there, but I do like this just double question marks. Like, oh, I don't know. You tell me. Okay, so I mean, the stuff down below is all kind of BS that I need to reformat. Waves hand proof. Yeah, just look at it. We begin by observing that if all subsequences of a sub n and b sub n. Hey, Amongarg, hi from a train. Ooh, you're on a train. That's awesome. Are you just like commuting, or are you like traveling? Is subsequence not a word? Do you have to hyphenate it? I feel like it should just be a word, right? How does my book say it? Hey, Mikias. How's it going? Okay, the book just says it as one word, so I'm going to say it as one word. Okay. Actually, I shouldn't even begin by observing anything that I was going to think that I observe. Off to a job interview. Ooh, good luck. Hope it goes well. Hey, SPQ. Since a sub n and b sub n are bounded, they must each have at least one convergent subsequence by the Bolzano Bolzano-Weierstrass theorem. If all subsequences of A sub n and B sub n converge, well, if all subsequences of A sub n converge to the same value, then A sub n is a convergent sequence. Yeah, Mickey's, I sure can. Type the equation out there in chat, or if it's easier, you can put it in my Discord. But yeah, so for today's kind of filler, at least for the first part, I was doing a question out of, well, last night I was reading Advanced Calculus, and there was this like to me fun question that I worked out a proof for the last part, like this last inequality here in my head, and I quickly typed it out on my phone, but I kind of felt the urge to type it out and LaTeX it up nicely. Just because, I don't know, it's kind of a fun question. I feel like I could use some practice with LaTeX, so probably do some algebra stuff as well once I get this done, but yeah. Suppose G is a group with exactly 8 elements of order 3. How many subgroups of order 3 does G have? Ooh. I know those for SPQ, but I still want to think about it for myself. But I don't know how you do that for sure. Or I do not know how you would do that. We'll say 4. Oh, doubting stack exchange. That's something I'm not in the habit of doing. Kind of curious to see I guess they're even debating within themselves, so. Okay, so I see Mickey has put their question in chat. Yeah, I can certainly help you out with that. Just give me 1 second, I'll go over to the whiteboard. Okay. Oh, didn't mean to do that. Okay. So the key for a problem like this is you want to set up a right triangle. So if we're given that sine of A is 3/5, we need to remember that sine is opposite over hypotenuse. So that means 3 is opposite, 5 is hypotenuse, and A is our angle. So let's go draw a right triangle and label things accordingly. I'm gonna label my angle A. I like to do the angle first because then opposite in the hypotenuse and, well, not the hypotenuse, but whatever it's opposite of the angle. So I start with labeling the angle first. We're gonna do the right angle too for fun. So the opposite of A we said is 3. The hypotenuse we said is 5. And now if we use Pythagorean theorem, we can get this third side of the right triangle. So I'm going to set up the equation 3 squared plus, I'm going to call that b for now, plus b squared is 5 squared. This is the Pythagorean theorem. Let's solve this for b. First, I'm going to get 3 squared and 5 squared. So 3 squared is 9, b squared is b squared, 5 squared is 25. Now let's subtract 9 from each side. We'll get b squared is 16. And now let's square root each side. So we get b equals 4. Technically, it's b is plus or minus 4 because you have to do a plus or minus when you square root each side. But this is a geometry, or because there's like a geometry interpretation here, we don't care about the negative 4. A distance of negative 4 makes no sense. So we take just the positive. So now instead of b, let's make that a 4. And now we have all the information we need to get cosine of A and tangent of A. So cosine of A, remember cosine is adjacent over hypotenuse. So the adjacent side to A is 4, and the hypotenuse is still 5. So I'd say cosine of A is 4 over 5. Then tangent of A is opposite over adjacent, so 3 over 4. And that's how you would solve that problem. Let me know if you have any questions, and I'll check on chat now in case you wrote anything already. Okay. So yeah, I hope that makes sense, Nikki. If you have any questions, though, please let me know. Yo, Obi, I'm doing good. How about you? You got your computers? Nice. I was just thinking that now with like your big time zone change, you're probably going to have another person streaming in the mornings. Which is not a bad thing. The mornings relative to America, at least. But that's awesome. I hope you're able to get like things up and running soon. Pack both desktops in one box? Wow. No worries, Nikias. But let me know if you run into any other questions, and I'm happy to help. What's happening with this group one from Phobos? Oh yeah, I guess that's a little bit beyond me with the isomorphism stuff. In any event, I'm going back to work on this little proof thing here for now. It's a convergence sequence. Likewise with B sub n. If both A sub n and B sub n are convergent, then slash begin equation slash lim, I guess we'll start with inf, n to infinity underscore, don't forget that, A sub n equals slash lim sub underscore n/2/infinity a sub n equals /lim underscore n/2/infinity a sub n. You dropped Get Us Off a few days ago, then went right into a stream from your tripod. Probably won't do that too often. Also, no US audience. Yeah. I remember seeing you mentioned that you did a little. Oh shoot, is the VOD up? I should have checked out the VOD because I definitely didn't see you when you were live. 4 a.m. stream. Oh yeah. Should be okay. I'll have to go look. Zach caught the end of it. Oh yeah, because Zach's in early bird. Well, hey, there's some cool Europeans who tune into math streams, and I'm sure they'll enjoy what the math that you're doing. Hey, Shed, 2 + 2 is 4. Quick maths, it sure is. Nice job. Can we do multiple equations? I guess we should do a separate one. Nothing much with me. How about you? If you catching my 9 p.m. Eastern streams? Wow, that's kind of crazy. I guess if they wake up in the morning. 3 over on YouTube says, how to show that there are infinitely many primes of the form 4n + 3, where n is a positive integer? I haven't done a proof quite like that before. We can Google it though. Just getting home from work. Oh, nice. Show there are infinitely many primes of the form 4n + 3. Could be like a Fermat's little theorem thing or something. You see Gojira in the back? Yeah. Yeah. There's like a surprising number of people on Twitch who have commented on that. Glad that there's some like Gojira fans around here. Germany and Poland. Oh, okay, yeah. Because they're like an hour or two ahead of like the west part of Europe. Every number n greater than 1 is divisible by some prime p, which also includes the case n equals p. Fair. If you know the Fallout series, I haven't watched it yet. I'm gonna steal a friend's Prime account, but I haven't had time to actually start an episode yet. I've heard good things about it though. Have you watched it yet? By minimality of n is divided by some prime p. You're 3 episodes in. It's goddamn fabulous. Oh, that's good to hear. I was just kind of assuming that it would be bad. Which would be a shame, but usually things based on video games aren't good. But it's that they're kind of starting to like break that trend a bit. The Dungeons and Dragons movie? No, I did. I don't know the last thing that I watched that was based on a video game. Now that I think about it. Okay, I didn't watch the World of Warcraft movie either. It was like a live play, but acted out. Okay. I mean, for a D&D movie, that isn't necessarily a bad vibe. Infinite. Wait, am I looking at the right type of question? Yeah. Infinitely many primes. Oh, okay. You can tell when people rolled poorly. So 3 over on YouTube. If you are still here, I think the idea of this proof is you notice that all integers can be expressed as 4n, 4n plus 1, 4n plus 2, or 4n plus 3. A prime number is certainly not of the form 4n or 4n plus 2 because those are even numbers and 2 goes into them. 4n plus 1 is not necessarily prime because you could have a number of the form 4n minus 1 times 4n minus 1. Which, how does that work exactly? I mean, they have a counterexample here, which might just be enough, but I'm doing like the general kind of division or multiplication in my head, like 4n minus 1 times 4n minus 1 is 16n squared minus 8n plus 1. Do we care about the minus 8n? Like, what is this actually saying? Like, how does that eliminate? Yeah, I don't know exactly how you prove that generally, but they do give a counterexample that 4n plus 1 isn't going to work. Because this is 21 is of the form 4n plus 1, but you can find divisors of it with 3 and 7. So you basically eliminate every other case except 4n plus 3. I can link you the stack exchange thread because it's like I can try and work through it for myself, but I think that's really just the answer there. Follow-up feels slightly like a playthrough, gives nods to the franchise, but still stands on its own. It's a checkout item, which is a subtle Easter egg. Oh yeah, that's nice. That's good. Follow, like, the games have a ton of Easter eggs, and I'm glad they're putting Easter eggs in the TV series. Mini nukes in a glass case, bobbleheads. Oh, nice! Camera definitely drifts into Vat's kill cam. Oh, nice. Or drops. Okay. That's kind of sick. I'm gonna go put my mug away quick. Is that how you've been filling your time without the computers, Obi? Just like watching TV shows and stuff? Like, I don't know what the heck I'd do if I was away from my computer for weeks like that. Like my actual like desktop anyway. I'm sure I could find something, but I'd have to do a lot of like planning. Thump a guy looks down, see an item, thinking of the ship. Oh, nice! That's the bats, yeah. Yeah, I never really thought about what bats like would actually mean like in the real world. But I guess it is that kind of like instant like quick draw shot. So I'm being a little premature with the point that I'm trying to make here. I guess if A sub n is convergent, Oh, the rocket launcher. Oh, okay, okay. Actually, which Hall games have you played, out of curiosity? I played 3, New Vegas, 4, but I never actually beat it because I hate it. 76, and I played Fallout 1. 3 and 4? Oh, you missed out on... Oh, dude, if you haven't played New Vegas, you absolutely should. It's my favorite game of all time. Stooky, yeah. So I was reading an advanced calculus book last night, just before going to bed, and there's this like problem. I'm not sure how easy it is to read on stream. That kind of just like sounded super interesting, and I had the idea for the proof in my head, and I typed it out quickly on my phone last night. But I kind of feel the urge to type it up nicely. So I'm doing my impression of you right now with a typing out some latex stuff on stream. Got it. A new mix on Epic. Oh, nice. Yeah, it's a great one. But yeah, I want to play through Fallout 2 at some point. I started to play through, but I didn't. I got distracted with other games. Even the original 2, the original 1 is super cool, but it's very different. Typical bedtime material. Yeah, I mean, I've been wanting to both keep learning analysis after the end of Zach's analysis course, and I've been wanting to relearn multivariable calc a bit more. And so this book kind of has it both, it seems. And just before bedtime is when it's when I'm in the mood to actually read through math books, I guess. I'm usually either too tired or I'm doing other things during the day, so. There actually is no abelian group with 8 elements of order 3. Oh, wow. You have 4, but on Xbox, so likely not playing Fahaba. Oh, okay. Fair enough. Can I zoom this in a bit more? So hopefully it's... Okay, yeah. But yeah, I'm sure Relief, like, maybe it's not like the most optimal thing to use, but I just wanted something kind of like quick and easy here. This thing here is annoying me. Okay. Recompile. So yeah, this is like a quick proof of the last part of the inequality that I tapped out on my phone last night in bed. But I think it'd be fun to like write it out a bit nicer. Yeah, I'm trying to set up another Fallout 76 playthrough with my friend, because I've seen that's like Fallout 76 has become it's had a resurgence on Twitch, at least it seems. Like I see a lot of streamers playing it again, and I don't even know what they updated, but I'm kind of curious to try it again. I don't know if I'm probably not gonna be doing it on stream, but I actually really enjoyed 76. They fixed things? Okay. It definitely needed a lot of fixes, that's for sure. I just realized my definitions. Wait. I do have the underscore here. Why isn't this going under? What? I do the exact same thing here as I do here, yet the n goes to infinity is to the side. It's not in display mode? What? Oh, do you need the double dollar signs for that, or what? Like, I only know very bare basics of LaTeX here. It's part of the reason why I'm typing this up in LaTeX so I can learn it a bit better. What would display mode be? Lots of errands to run, so you have a massive amount of downtime unless the kids are in bed. Oh, fair. When you have Wi-Fi like some kinds of animals. Slash display mode. Oh, okay. Thank you, Stuki. Display mode. Slash display mode. Mode. Really? Oh no. LaTeX hates me. Yeah, I guess you probably wouldn't have a ton of free time if you're getting settled into the new place. Hmm. I mean, it's probably not that big a deal. I don't know why display mode it isn't working, but I think the double dollar signs puts it onto a new line, which I don't want either. We can see how it looks. Display style? Oh. Yeah, I definitely don't want it on a new line. Stupid. Slash. Just try typing in display style. The fact that it's not auto-completing kind of concerns me, though. I wonder if... Oh, okay, no, it works. Never mind. AS Gamers, can I ask, are you familiar with programming? Kinda, yeah. So, I have a minor in computer science, but I also got that minor like 5 or 6 years ago now. Actually, yeah, like 6 years. Time flies. So I learned a bit of Java, C++. I know a tiny bit of Python. I used to know MATLAB. If it's like a conceptual programming question, I can almost certainly answer the concepts. The actual like writing code though, I've become pretty rusty at. Delphi? I've never heard of that, no. Did you go to the grocery store or a cafe to download the podcast, then when you came home you couldn't? Oh no. I kind of feel that. I had like a 2 or 3 day streak with no power like a month or two ago. And I was like going over to my mom's house, like charge my phone and like download stuff and all that. There's a fifth distinct subgroup of order 3 with distinct elements. Okay, I'm definitely not following that. Breaking math? What's that about? Breaking math podcast. I assume it's about math, but I'm curious if they have like an emphasis. Advanced degrees in electrical engineering and industrial engineering. Ooh, as a pure field. Engineers talking about pure math. Okay. Hmm. How to deal with nuclear waste in the future. Okay, that actually does sound super interesting. AI and neural nets. Ooh, okay. That could be an interesting one. a sub n. Here, does this show up how I want it to show up? Okay. If both a sub n, now give me the point that I wanted to make originally, are convergent, then slash begin equation slash end equation started with Sophia being the expert, was Gabriel's tutor in college, and Gabriel talking about things he found online and read about during the week. Oh, cool. That's a nice like format with an expert and someone who's new to it. It's actually like in general for learning, it's really nice to hear someone else like learning, I guess. I remember like when I first started playing League of Legends, like that was actually how I was trying to learn just like what the hell you even do in that game, and the first video I found was basically that same format with an experienced player showing his new friend how to play, and it's like, oh, okay, because like me and that new player had the exact same questions. Circle context. Oh, that's awesome. Adding in the color comments. Oh God, okay. Let's copy paste this stupid thing. That's adorable. Me learning League of Legends like that. I guess so. I was in high school at that time, I think. All right, cool. This is, I think, what I want to do. If he's going by different name at the beginning, just so you're not surprised. Oh, really? That's good. I think it's really funny. It makes sense to preserve anonymity, but I really like hearing the names that people choose for themselves on the internet. Because I feel like there's some like psychology that happens there, I guess. Hey, oh God, I'm gonna mispronounce this. Lucia Milkovich. No, I'm sure that's terrible. But anyway, your question is, how do you do the absolute value of x equals the absolute value of 2x minus 1, for example, when there's two absolute values? Not an internet name change? Oh, okay. Never mind, then I misinterpreted. That's a good question. When you have two absolute values, what do you do? They're not like nested, which I know how to deal with, when they're just like separate. Honestly, I kind of want to graph it. I don't know if there's a quicker way to do it though. I think the question is either, or I think just like, I personally would do it graphically, but I'm sure there's an algebraic way to solve this. Problem x equals 2x minus 1. Split into cases, do it algebraically. Like, are your cases, do you have 4 different cases to deal with each like kinds of plus and minus? Start with x greater than 0. Is it overcomplicated, SPQ? I'll read that more after I do this. Because I'm not even like in the actual fun part of the proof yet. This is like the boring setup stuff to me. Start with x greater than 0 and see what happens. Okay. So yeah, I'm just gonna say Lucia. So I don't know if that's actually right though. You can do this algebraically, it sounds like, or you can do it with graphs. As someone who hasn't solved a problem exactly like this before, my inclination is to graph each of them and find their intersections. But I would like to learn the algebraic way, so we might struggle through that. Oh, we might need like a number line if we do it algebraically, which is okay. So you have the absolute value of x equals the absolute value of 2x minus 1. Set as distances into your pseudo-graphical invention. It breaks my brain when we have the two absolute values, though, to do... I do it that way if we didn't have the absolute value. Like if that was just like a 2 or something, right? But when it's x, like I don't know how to deal with that, I guess. Do the next time I'm on? Oh yeah, sure. You said some, you meant sup? Okay. So Philip is saying let x be greater than 0 and just kind of see what happens. So the thing with that, I guess, the thing with absolute values, you have to worry about when they're positive or negative. So just kind of arbitrarily, like we're gonna look at this one and we're just gonna like take whatever we need to get this one to be positive, just kind of see how it behaves. I'm trying to do the algebraic way first. I'll also show the graphical way though. So we just set x to be greater than 0. We know the left side is positive. The right side, it's gonna, when x equals 0, it's a -1. So we're gonna have like a section. I guess, how do we like, okay, so we need x to be greater than 0 and x is gonna be less than a half, which means this is this is positive and that's negative. Like, yeah, I maybe need to figure out the different transition points for where these become positive or negative. So between 0 and a half, that's positive. That's negative. So we set up the equation positive x equals -2x minus 1 and solve for that. And then we do x greater than a half and x less than 0. I don't like multiple cases, but what can you do? Yeah. Okay. So I think it's how we approach it. So we can solve this for x and we have two other cases to deal with here. I guess, what about equal to a half or equal to 0? We can say this is greater than or equal to 0, because that's still negative. E. I don't know if that actually matters. I'm getting a little held up on the I think this is okay how I wrote it. So let's solve this for x. X equal to -2x plus 1. Add 3 or add 2x to each side. We'll get 3x equals 1. X equals a third. And just as a sanity check, let's immediately plug it back to the original and make sure I didn't do something horribly wrong here. Absolute value of a third is equal to absolute value of 2 times a third minus 1. Absolute value of a third is a third. 2/3. Ah, I did it right. 2/3 minus 1 is -1/3. The absolute value of -1/3 is +1/3. Okay. I managed to do something right for once. Okay, so we already got one solution here. We may have more though. So let's, we've looked at, I think this is actually the tricky case that I skipped straight to. I think the other cases will be a bit simpler. Let's look at x greater than 1/2 now, or equal to. Here, exactly at a half, that'll be 0, And if you're greater than half, it'll be positive. And if that's a half or bigger, that's just always positive. So here we set up the equation x equals positive 2x minus 1. So everything is positive in this case. And then we do the same exact procedure, solve it for x, we'll hopefully get a solution. So we subtract 2x from each side, we get negative x equals negative 1, so x equals positive 1. As a sanity check, I'm going to plug it back in. 1 equals absolute value of 2x minus, 2 minus 1. Which does work, doesn't it? Because 1 equals 1 the last I checked. Okay. So we got a second solution here. Now the only other case is if x is less than 0. I guess the or equal to doesn't actually matter here. So if x is less than 0, actually, I guess, I don't know. Actually, yeah, it should, no, it should not be or equal to. Because we want x is going to be negative here. This will also be negative for any negative number on the inside. So we'll stick a negative sign in front. Okay, now we solve this for x. Could we have just from the start not worried about the intervals and just done every combination of plus and minus? I guess we didn't do, yeah, I mean, we kind of just ended up doing that. I don't know if that's always valid though. You might get extraneous solutions if you do that. Add 2x to each side, you get x equals 1. So we get a repeated solution here. So I guess our solutions are x equals 1 and 1/3. And actually, I guess that makes sense for absolute values. I wouldn't actually, can you have 4 solutions in absolute value? Not if they're both facing up, right? Oh, you're right. That's a good call, Phobos. So that's why the inequalities are important here, because we set x to be less than 0, but we got a positive x. So we'd actually throw the solution, oh, I'm sorry, we would throw this solution out entirely because it came from the case x less than 0. But by coincidence or whatever, we happen to get x equals 1 from this solution where it is valid. It's a funny little distinction there. Okay. X star is a positive distance. You can draw the mark at -1. Or yeah, 2x, you usually draw the mark at +1. So yeah, Lucia, I guess that's how you do it, the algebraic way that I explained terribly. So let me know if you have a question. I'm kind of interested to do it the graphic way, and then looking, or I guess I don't know if I'll graph them, but at least look at Obi's way that's being put in the Twitch chat. And hello to Vilmer London over on YouTube. Oh gosh, what is that? A proof by induction with the power rule for derivatives? Can you do induction on that? I'll hop over to the Twitch chat in case anyone wants to like start to think about it. I'll think about it more after I have explained this one a bit better. Oh, my pronunciation is pretty good. All right, thank you for telling me that, Lucia. I feel bad when I butcher names that I'm not used to, but I'm not used to them, so. Okay, so I'm curious to see Obi's number line idea. So if we draw a number line, 2x minus 1 is the distance between the number 2x, whatever it happens to be, and +1, because the distance from 2 to +1 is 1. The distance from 2 to -1 is a weird like sign flipping, but if it was 2 to -1, the distance is 3. So we interpret this as the distance between 2x and +1. So let's we mark We'll be saying mark +1 on the number line. And then what? Hey, Eldritch. Can draw the mark at label number line as 2x. With distance x in either direction, because x is the actual distance. I don't know how you really interpret that. So to give a good night kiss? Oh, well, thank you, Eldritch. So I actually don't really know what you do with this, to be honest. I feel like I'm stuck here, so I guess you could call it like 1 minus x and 1 plus x. You have a point? Okay. So yeah, we can do that. Please suppose that x equals 4 or something. It's an easy answer. This is slightly harder. Okay. Yeah. So I don't know. It's not like Lucia got their answer, so I don't feel the urge to harp on it too much. I'm kind of curious to see if there was like, if you could make that easy number line approach in the same way. Maybe let's take a look at Vilmer's question, if you are still here, Vilmer. 2x equals 1 minus x, or 2x equals 1 plus x. Oh, that will get us the same answers. Oh, that's neat. Okay. Okay, that's actually kind of cool. Expression is the other. Okay. Yeah, that makes sense. I was trying to do that in my head, but I was like dividing by 2 and it wasn't working. Right, I wasn't doing the division quite right. So I wasn't thinking about it like that equation form. So, okay, Vilmer. This seems like a weird place to use induction on. I'm not exactly sure where it's going to go, but I can try kind of blindly following the steps of induction and see if that makes sense. But I've always learned induction in a non-calculus context, and calculus never really involved. I guess it kind of involves induction if you want to talk about series, but I think I was learning about the two very like separately. So when they get merged, I get a little scared. But there's no reason you can't do it, I guess. I'm trying to wrap my head around if there's any issues. I guess we're only proving it for integer ends, right? Yeah, that's kind of the issue with the power rule, or proving the power rule via induction. You can't really prove it for every real number. Was there more to the problem that where n is a positive number? Oh, okay. That makes sense, Obi. That's what you're thinking too, Vilmer? Yeah, so it's saying n is a positive number, And to me, that means positive real number, which we certainly cannot prove with induction. We can prove it for positive integers, but this proof isn't gonna apply to rational numbers or irrational numbers, because those don't work. Actually, do rational numbers work with induction? I guess they technically would if you set it up right, but I don't want to think about that because I don't know how that works exactly. So I'm going to modify the problem a bit, and I guess say n is a positive integer, because I think that's important. Yeah, at n equals 1. Oh, you meant integer. Okay, thank God. N be a positive integer. All right, so I guess let's start with our base case. Well, actually, let me write down the statement again. Prove y equals x to the n implies y prime equals nx to the n minus 1. Okay, so I guess I can do this with induction. I guess I don't see why not, now that we know the setup. So the base case is n equals 1, because n is a positive integer, so we start with those from 1. That means we have y equals x, I guess to the 1, but it's really just equal to x. Actually, that looks like a prime. I'm going to write just x, because I don't want to get the notation confused. Y prime, I don't know how much they want us to prove it, but you just say y prime is equal to 1 times x to the 0, which is just 1. And I'm just going to say that checks out, because we presumably prove that 1 is the derivative of x in some other context with like an epsilon delta proof or something like that. I hope we don't have to go through all that. Or I guess the limit definition of derivative would be possible too here. 2, we assume y equals x to the n implies y equals n x to the n minus 1. Case for rationals is much better than reals. Oh, really? Even if it's like positive rational SPQ? I mean, that's kind of like a for fun question, I guess, but if it's positive rational, it's maybe, like, I was assuming you could do some kind of like mapping like you do to map the integers to the rationals. Whatever mapping happens there, you could apply to an induction, but I don't actually know how that works, so I might be off my rocker there. Y equals, I feel like for induction I've been criticized before that like they normally switch from n to k for this part, I think. I forgot the prime. X to the k, I guess how we would set this up. Interesting. So, oh, this is kind of, I think I see what we do here. Oh yeah, OB. Yeah, this is a product rule. Because we're gonna use both, we're gonna use the base case also here, which is kind of neat. All right, so Vilmer, I don't know how to explain how you see this stuff. I was just playing around with it. Let's start with the left side of our implication here, because we want to get to the right side. If we have y equals x to the k plus 1, we cannot just blindly apply the power rule here, because that's what we're trying to prove. So we have to do something weird. And we want to use the thing we assumed in step 2. So the way that I kind of was playing around with things in my head, I was kind of randomly doing manipulations until I got something that makes sense. Or, well, makes sense is probably a bad like phrase to use, but until I got to something that would let me use this induction hypothesis, which is x to the k plus 1 is the same thing as x to the k times x, because with exponent rules, the exponents would add with when you multiply the same base. And we know how to derive x to the k by the induction hypothesis. We know how to derive x because we did the base case. So why can't we just do a product rule here when we do this derivative? So if we do the product rule here, I'll derive x to the k first using that formula, kx to the k minus 1 times the original x plus, now the original x to the k times the derivative of x is 1. And let's pray that this cleans up into something nice, basically. First, let's combine the x to the k minus 1 and the x. We get x to the k plus x to the k, right? And then we factor out the x to the k. So we get k plus 1 times x to the k, which is what we wanted. That's kind of neat. Oops, prime. So yeah, I'd say that's actually our proof right there. Kind of a weird proof to do. Because I feel like you haven't actually proven stuff that's really that helpful, but it certainly works. It's like I'm saying it's weird because the power rule doesn't just apply to positive integers, but if you arbitrarily make that restriction, you can definitely do this induction. So let me know if you have any questions about that. It's definitely a very unintuitive proof. Now do it with the quotient rule, half trolling. I mean, if you wanted to quotient rule that, we have to do like 1 over x. I guess you would. That's, I don't know. It's a lot of algebra. So thanks, Vilmer. Yeah, no problem. Thanks for the question. Ordered rationals is something ridiculous? Okay. Yeah, I guess the rationals aren't really as clean of an order as the integers are. Okay, so what was I saying here? I just proved the case that these could all be equal to each other. So that's already a big part of the proof done. SPK was saying something earlier, but then I think they may have taken it back. Let me scroll up. You don't like what you said, NVM. Okay. Oh, so yeah, if those facts about sets, if we could just use those, then that'd be kind of nice. Those things were provided in the book, but yeah, that would kind of make the proof a lot easier. 0 equals 1 prime equals f times 1 over f prime. F 1 over f prime equals 0? Oh, I guess so, that equals 1, and you still have the prime on the outside. Huh. Wow, that's kind of crazy, SPQ, that works. Hey, Zach, yeah, So, last night before going to bed, I was reading this advanced calculus book, and there's a question from it that was really intriguing to me that I repeated at the top of the page here. And I kind of hurriedly typed out an idea for proving this part of the inequality on my phone. But I don't know, it's kind of been like occupying my mind, and I've been feeling the urge to like nicely type a proof for some reason. That'll be some good like LaTeX practice. Yeah. There's another one after that that looks kind of. I don't know how I do it, but I'm kind of interested in thinking about it too. It's if you have a convergent sequence to 0, then the sequence of arithmetic, I always forget how you pronounce that, means also converges to 0. So you define a new sequence, sigma sub n, that is a1 plus a2 plus a sub n over n. And apparently that would also converge to 0. It kind of makes sense, I guess, but I've got to think about it. Convert to the ways of LaTeX. I mean, I've written some things in LaTeX when I was like a research assistant doing my degree. But yeah, I haven't had much reason to use it since. But I don't know, I just kind of want a nice-ish looking document here for this proof. So kind of the cool part of the proof, I think we can finally get into this. I don't know exactly how the rest of so I've only worked out the proof for this step. The rest of this, I don't really know how I'm going to prove either of the other two inequalities yet. I mean, we really just have to find a case where it's true, I guess. Well, we've shown that it could be equal. We have to show it's not greater than, and then we can show a case where it's less than. And I think that's sufficient. That's basically what I did for this last inequality over here. Okay. Minus a sub n minus b sub n. Well, that helps, like, minus supremum of minus a is the infimum. Oh god, that hurts my brain. Huh. I'm thinking about like the reflections that happen. Thanks for lurking, Zach. I guess so. That, yeah, I feel like the proof, like, if I've worked out the proof for this last inequality, the proof for the first inequality should be pretty similar, and I assume the middle inequality should be simple, but I don't know exactly how it's going to work yet. Getting ready for your final exam tomorrow? Ooh, good luck. And Ahmed Ahmedel over on YouTube, an example of Laplace transforms. I don't have one offhand. I think Paul's notes goes into Laplace transforms, right? Where would Paul do Laplace transforms? Oh, maybe the section titled Laplace transforms. That'd be a good place to look first, right? Yes, I figured it'd be something like that. So yeah, Ahmed, this is my favorite site for everything calculus and differential equations. I would go through, if you're looking for Laplace transform examples, just look through the sections in here. So they have a whole bunch of really well chosen and well explained examples. Oh yeah, in the DE part, yeah. I was getting it mixed up with like a Fourier transforms in my head at first. So I was getting like a little confused on where I should look, but yeah, I got there in the end. The inequality before, I think you can do the idea above. Well, we still have to prove it for the infimum, right? And so, I mean, I guess I was going to do the reverse direction where I start with proving it for the supremum. Transforms are transforms. Are the Laplace and Fourier transforms actually not that different? Wait. It does kind of look like a Fourier transform, doesn't it? The plus is real and complex, 4a is only complex. That's still kind of crazy that they look nearly the same, though. I didn't even realize that. What the hell? I guess the bounds for the integral are different too, but I never made that connection in my head. I know they are like different, but they're surprisingly similar. It's part of your presentation tomorrow? Oh, really? There you go. I'm helping you study. Created their own specialized G. Oh, okay. That's the Fourier part. Okay. Assume the limit of the lim inf a is equal to minus lim sup a minus a. I guess so. I don't see why it wouldn't be. Lots and lots of convolutions. Yeah, I learned convolution integrals. I guess it would have been for differential equations, right? I don't remember at all how they work though. I just remember you get that fancy like F star. That looks cool. I think Paulson's actually does convolution. Maybe, I don't know. Okay, what parts of my hastily scrawled notes have I covered? Okay, so I want to start working on this part where we need to I want to do this part of the proof, which is I want to eliminate the case that this is greater than this by thinking about how a subsequence in A sub n that does not contribute to the limit superior can basically cause, like I think about in terms of waves like destructive interference in B sub n. Which to me, like for this proof, the metaphor of using like waves in constructive and destructive interference was what made me realize like how this proof actually works. Lim sup minus a plus minus b is less than or equal to lim sup minus a if and only if. Oh God. Okay, so if we can prove that, that's basically how we would transfer the proof for, say, like this last part over equivalently to the infimum case. That could definitely come in handy, because that part I haven't even slightly thought about yet. The first is the last part. Yeah, so we still have to do some work in, oops, I don't want dollar signs, I want percent. It implies the, yeah, so if we can prove it for lim sup, then we can show that implies it for lim inf with what you said, which is clever. I would never thought to use like that there's a property like relating the supremum to the infimum like that. It makes perfect sense when I see it, but it's not something that I think I've seen before. It's going good, Ben. I'm not trying to do anything too like crazy yet. Like I was thinking like, you know, just 3 sections and then the question and the proof, but it's a lot of like little things that I I've been learning, like doing bold text or doing a bullet list, all that good stuff. So, so far so good. You found itemized? Yeah. So the part of the proof, I've justified the equals case. So now let's focus on the superior limits and throw out the greater than case. We now focus on proving that, is there like a not greater than? Like, slash begin equation. Time for bed? Oh, yeah. Thanks for hanging out. Have a good night. Item symbol slash command to make the list look funny? Like, so you can do any bullet point you want? Oh my god. Can you do like emojis? I don't know what the I don't know how you would do that though. Should be able to do emojis. Slash item. Oh yeah, so you can just do a number. What's a good emoji? Oh, dude, if I could get my Twitch emotes in this, that'd be pretty pretty sick. You'd like for LaTeX to support feels dank, man. Unicode, that's what we want. If I just copy it, oops, not that. Can I paste it? Oh no, doesn't like that. What is that? That looks like Morse code. Supposed to be Sonic? Oh, okay. You're doing like ASCII art? Okay. It doesn't seem like Overleaf likes it. Ah, what did I just do? Oh, there you go. A DJ. Oh, well. Sonic looks slightly distorted. Yeah. Oh, wait, no, this is the equals case. I want to come up here. I assume it'd be NLEQ. Where does this stupid thing start? Right there? So just slam an N in front of that and hope for the best. Hey. Oh wait, I didn't want that. GEQ. No, not, it's not even GEQ. What's greater than? I want non-greater than. He lost some rings, yeah. Hi, hello to you too, Kai. Slash GT? Okay, so if I do slash NGT, is that not greater than? Nope. Okay, no, you know, I can just rephrase it and have it be greater than. Slash not slash. Oh, God. I want it to be strictly greater than, I guess. Oh, wait, you just do the character. Duh. There. Okay, I'm just gonna do that. We now focus on and instead of trying to get a slash through it, I'm just gonna showing it cannot be that this thing is true. Okay. This is, we now focus on showing it cannot be. This is so weird on showing. There should be a better way to phrase this, right? We now know. We now show the following cannot be true. There we go. That's a better way to phrase it. You can even do I'm being kind of lazy with that punctuation, aren't I? Slash text dot. Okay, there. So this is the part of the proof. This is a part of the proof that was a little bit tricky. Get rid of that. I don't think I need that. So my idea here is to, since the more interesting case if okay, up here I discussed the case if they're both convergent sequences, then you just get equality by normal limit properties. But the more interesting case is if they aren't convergent. A sub n, and we can say not convergent in a more helpful way, or maybe a more direct way for this proof, which is as a subsequence that does not, oh, we need to name our lim sub n/2/inf a sub n equals a, capital A, let's say. And I don't know if we'll need it, but like we can name B's lim sub. As capital B. And that a sub n has any subsequence that has any, or has a subsequence, or at least one subsequence that does not converge to A. Oh God, I need display style. So we need to name by the definition of limit point, there exists an integer n, n greater than or equal to small n, space small n, such that, what am I trying to say? I want to get to the part of the sequences that are actually converging to things for the parts that do converge to things. So, actually, do I want to do that? Oh, what do I want to do? I might be I may be getting mixed up with the next part after this. Yeah, I think I do want to do this such that how do I phrase this though? I want to only consider the sequence and subsequences past this kind of like point of where it starts to converge. Such that every neighborhood of A maybe let's start by just defining an n that's the maximum for A and B. N1 or I guess I'll say n sub A. No, it's fine. Corresponding subsequence. Such every term in the corresponding subsequence for A is with in a neighborhood of A, except possibly for a finite number of terms. That's kind of awkward phrasing, but we could maybe go with it. Likewise, define Donkey! Thanks so much for the raid. Well, welcome in, everyone. You're playing Rainbow Six Siege? Ooh, how's that going? Ambigula, hey. Came in just in the right time. Yeah. Hope you all are doing well. Well, welcome in, everyone. I'm being about as nerdy as you could possibly be right now. I saw a math question that actually looked fun, and I felt the urge to actually like nicely type up a proof for it. Lofty, hey. We went for something a bit different tonight. It was good fun. Yeah, that's good. I never played Rainbow Six Siege. I've heard it's very toxic, but I do like the idea of the game. A fun math question? I know, it's it's weird, but I read it last night, and like I haven't been able to get it out of my brain, and I feel like typing up the proof in a somewhat nice looking document would put my brain to rest. So this deals with sequences and how they behave in the long term, and it's it's a thing. I think it's less toxic if you have a full team of people, so you know, to play with. Oh yeah. If you got a stack of friends, then I'm sure it's a great time. Whoa. Define nerd if and only if unnerd conversion is non-trivial. Yeah. I've heard of eggs come in currents. I never thought friends come in stacks. Well, you know, that's why Stack Exchange is such a popular site, you know? /GQN2. Oh god. I feel like this is kind of sloppy phrasing, but I'm just gonna go with it because I'm not that concerned with this part of the proof, I guess. Corresponding subsequence in A sub n for A for B sub n. And take n, big N equals the max of n sub 1 comma n sub 2. And this is how we're going to shortcut to talking about the n part of the sequences that we actually care about. There's so much like minutia here that like I'm losing sight of the actual idea. Might be too much for you. I don't blame you, Begula. It's becoming too much for me. Like, I feel like when I can often get the idea of a math proof, but actually writing things out, I'm not very good at. I feel like I should be better at it, though. Oh, should I do slash max? I don't know if that's going to break LaTeX, though. Okay, no, we're good. Why writing words in math? Because that's just how math is after a certain point, for better or for worse. Yeah, there's not a single... Is there a single number on this actual page? There will be eventually, but yeah, so far we haven't put a single number. Oh, I did type out... Oh my god. I thought it was /inf, apparently it's /inft. Okay. There we go. I'm using the word likewise a lot. Let's say it's similarly. Similarly define that. Okay. So we're trying to throw out the case where the left side is greater than the right side. And we do that. I think I can see a good argument for this, but I never liked writing a proof scenario form. Yeah, Fembox, I agree. All the time as I've been going through this book, I just think about the idea of the proof and then I like move on because I'm too lazy to actually write it out. But I don't know, this one just kind of caught my eye here. And I feel like I'm kind of honing in a little bit on this paragraph, but you know, it's your book, Rudin. Yeah, this is what is it? It's part of the International Series in Pure and Applied Mathematics. This title is Advanced Calculus. It is by R. Creighton Buck. I don't know if that's showing up too well, but basically, my differential equations professor gave me a complex variables book and a differential equations book in the same series, just so I could have them, and because I was doing a project involving series of differential equations, and I forget if complex variables was just for fun or not, or I was doing something with them. But I was like, oh, you know, these books are like, I like how they're like novel sized. And I was kind of interested in the chemistry books on other topics too, so I looked in the same series for other things I might be interested. So I got the advanced calculus one off of Ava books, and I got I got a second one. It's on my bookshelf right behind me too, but I can't remember it. Oh yeah, on modeling, which I should really look at the model at some point too, but it'll be for future me. Dude, I'm getting this done at a snail's pace right now. That's fine. I shouldn't be doing option. I want to actually like get it done quick, but I like to like hang out and get like feedback from people too, I guess. So your senior level analysis homework, can I see? There are no numbers. That's the point. It's about finding relationships, but there are no numbers. Yeah. Oh, actually, that's not... I did just put a number in the proof now. We have subscripts for the N2 and N1. By the definition of superior limits, all of the terms in any other subsequence of A sub n must be less than the terms of the subsequence, and less the terms of any other subsequence in A sub n. That's the idea I'm trying to get across. I feel like this is sloppy phrasing. And how does this help us again? Oh yeah, because we want to be not greater than. So I kind of want to rephrase. I want to say like maybe bounded above. Readable translation for one ladies on Breaking Math. She became a high school math teacher. Oh, nice. The terms in any other subsequence of A sub n are bounded above by the terms in the subsequence, or corresponding with A subsequence in A sub n. I think there should be a better way to say it, to refer to the subsequence, but we're going with this. Yeah, and so on my phone, I was struggling to phrase this too. It cannot be that left-hand side is greater than the right-hand side because no terms in the second subsequence can increase the left-hand side by more than the first. So I feel like there should be a much more proofy way of stating this. Maybe there's like a simpler way of saying it. Therefore, for any subsequence, just start. Zach did should show up before actually. He went to go study for a final, but I think we did summon Zach for like a little bit. Yeah. Therefore, for any subsequence. Oh my god. Should I want to name this sequence that converges to A, or the subsequence that converges to A. Let one such sequence or subsequence be Can we just say a sub n sub 1 for the not a subsequence? Let the subsequence in a sub n that converges to a be a sub n sub a? Does that work for, can you just keep on adding underscores on? Oh god. Overleaf is like, what have you done to me? And when using multiple subscripts? My Pip-Boy bobblehead lost his accessory. Hope it's in there somewhere. Oh no. So, oh, do we do like a nested subscript instead? Is that how this works? Found it? Okay, good. A sub n sub 1, a sub n sub a. Okay, cool. We figured it out. I guess we don't really need those braces on the outside, do we? Term in a sub n sub a. Yo, Joe, how's it going? I am unironically, just for fun, typing up a math proof right now in like fancy math. It's called like LaTeX, like the formatting language for math. So it's like it's something I'm doing for fillers, since there weren't people in chat with questions, but I also just kind of like want to do this. How's it going for you? Is it true that the limit sub of a sub n plus c is equal to the lim sub of a sub n plus c for c is some constant? Ooh, I would think so, yeah. That's just I could phrase it as like a property of limits. Well, lim sub doesn't really follow the limit properties, though. That's the entire point of this. You're moving down. You're moving further south. You already moved south once. I didn't. What? I mean, you don't have to say in the chat if you don't want, but like, where are you moving? If you ever like DM me, that's cool too. Let's see what Obi put. Oh, the lock broke off. This is a cool bobblehead. This must be the one for lock picking. That's cool. Glad that the thing was found. Cause oh yeah, with minis. Or do you have a hobby of lockpicking too? That's news to me. A equals is less than or equal to 0. We need to justify it if we do that like constant thing. It definitely feels like it should be true. Because I think about in terms of functions, it's like a vertical translation. Hey, Mohammed. I do remember you. Um, what would that do for us, SPQ? Or like, I guess, what's the point of this? You do pick, but in English restricted within the house. Really? Oh, I just saw the DM now, Joe. Okay. Okay, so now the thing I just did before simplifies this statement a lot. What did I just do? Oh, that's how that works. I don't want to do that though. The terms in a sub, we're saying a sub n sub 1 are, we can say strictly less than a sub n sub a. Carrying your pocket knife accidentally? Oh, yeah. Locks with force rather than finesse is more fun. You only picked like 2 locks so they can't rust. Because they can rust? Really? Huh. Not sure if your idea helps, maybe. Okay. Yeah, your math exam coming soon. You're bored? Ooh, well, good luck with the exam at least, Muhammad. Hey, Critical. So you definitely can. I noticed that you posted a few questions, or you kind of posted questions that are kind of similar to things you've asked before, and I that's okay. But I kind of I need to hear like from you what parts of the questions you're not getting. So I feel like I'm repeating myself and not actually helping you. So when you just post a question like with no explanation or anything, I'm not really sure what to do with it because I kind of just repeat myself for the question that was similar. A 3-inch blade without any reason? Wow. So if you want to get asked a question, but if similar to something you've asked before, I kind of need a little bit more. Um, please watch something fun for a few seconds as a break to everyone's minds. No. If you want, you can watch something fun for a few seconds, but I want to do this. Okay. I guess, okay, therefore, I think I've nearly gotten to the point here in throwing out the greater than case. Oh, you couldn't pick the lock on the shed? Dang. This feels like I'm kind of there. I feel like it's maybe someone might consider it a leap, but too heavily rusted. Oh, that'll do it. Then, I think we're gonna add b sub n to each side, and that's what we want. A sub n sub 1 plus b sub n slash less than or equal to a sub n sub a plus b sub n slash display style slash lim sub n slash to infinity the maximum value attained by a sub. What am I saying? My brother asked, you have some keys somewhere, right? Well, yeah, somewhere and beyond. Mohammed, you'll be fine. Let's see if the question is critical. Series is convergent or divergent? A circular saw is the key? What do you think for this one before I say anything critical? You really don't know? So my first instinct here was to try to compare it with the geometric series. That's not right though, because if you just think of a geometric series, if you only think about e to the negative k, that's like 1 over e to the k, and that r would be less than 1. But the k kind of messes things up, because you would think that geometric sequence converges, but you don't really get a helpful comparison test or anything like that with just that geometric part. So my next thought is that this is probably integral test, because you could definitely integrate this. and the terms are positive. Oh wait, are they decreasing? E to the negative k. Yeah, decreasing. Because e to negative k is decreasing very strongly, and k is only increasing weakly. So we expect the entire sequence to be decreasing. I expect this thing to converge, to be honest. So I could try and, I mean, I could show you the, I'll cut to the end result here to see what the answer should be. I expect it to be convergent, but I think that this is one that you should try to, if you know what the test is, you should try to follow through with the test on your own and then tell me if you weren't able to get this answer of 2 over e, which means that it should converge. Okay, I think I know what I was trying to say here. The maximum value attained by the limit with the thing in parentheses. Integration by parts, yeah. Underscore n to infinity. Dude, this isn't like the clean conclusion that I was hoping for. This is the idea of the conclusion. I want to be able to actually write this succinctly. Oh wait, I did mess up. That shouldn't be less than or equal to. That should be just less than. Ah, God. Is okay. No, I think by the thing I just wrote, I think this will be a decent enough conclusion. A sub n sub a plus b sub n. Period. So what have I actually argued here? It's the question. That there is no other subsequence in a sub n You know what? I actually want B to just straight up be a convergent sequence. Well, oh, that's not good though. Oh, for the series that Critical posted, 2 over E, according to Wolfram. K equals 1 to infinity, K e to the negative K. It's the bound. Oh, you do match the lower bound, right? You don't do anything weird? Okay, yeah, you do match that lower bound. Okay, good. K e to the negative K. Is that some weird version of integration? Oh, wait, what? I have problems following that first equality, that K e to the negative K is equal to K e to the negative Kx over X, which approaches 1? I don't know how you say those are equal. It's a substitution. Oh, well, oh, you're saying X approaches 1, not divided by X. Oh, I guess so. Okay. And then you derive it? So you're claiming that X is some variable that's approaching 1. I'd never seen a sub like that. That's kind of interesting. How did differentiation help? Oh, but yeah, because sum and differentiation are linear. Oh, just get rid of the K in front. I get it. Just to force it to be a geometric series. Wow. For K equals 1 to infinity, it's 1 over e to the x minus 1, which you differentiate and let K... What do you do with x? X approaches 1, so you just plug that 1 in. Okay. Huh. I've not seen a technique like that before. That's kind of crazy. I guess it makes sense. Like a geometric series that's not going to be the same as an integral, so it would make sense unless you have like a step function. Like a geometric series is basically a Riemann sum. I guess it does go to infinity. I don't know if that's the best like metaphor to use. Maybe it's not too bad though. Yeah, I think I'm following that part. I guess I'm trying to justify now why you get a different value. I assume it's okay as long as it's finite, which means that it will converge. What does e over e minus 1 squared come out to? I wonder how close it is to 2 over e. .92 or 0.73? That's not too far away. Because with the decreasing function, your Riemann sum would be an overestimate. So I assume a geometric series is like Riemann sum with step size 1. To make sense, it would overestimate the integral test. Huh. Hey, Anders. That frog is adorable. Am I happy with what I've written for the crazy man? Oh yeah, Grothendieck is cool too. Is it adorable too? You know, I guess he's adorable in his own way. So basically the story so far is last night I was reading a calculus book and a question from it really intrigued me. And I hurriedly typed out a part of the proof on my phone, but I just kind of felt the urge to like solve it out more properly and actually write up a proof nicely. So the question I repeated up at the top of the page here. And I have the and I've proven the case where all of these can be equal to each other. At least I feel I have, I guess. And so I'm working. Actually, I guess it's I do that down there, and I'm now working on just the right inequality over here and trying to throw out the case where it's greater than rather than less than. The actual mechanics of doing that are kind of tricky though. I'm not entirely happy with how I presented it here. So I'm having a time even following my own proof here. I think I just need to add on one more thing for B sub n here, and I think I'll be happy with it though. Similarly, define B sub n sub B and B sub n sub 1 such that B sub n sub 1 is less than B sub n sub B, and then the maximum value is attained by B sub n sub B, which equals the separate lim subs. n/2/inf d a sub n plus /lim sup underscore n/2/inf d b sub n. Okay. Have a good time dealing with lim sup and lim inf. Yeah, it's really tricky to deal with these things because you have different subsequences happening. This is my first time ever even hearing that they exist. Is from this book. All right, so I think we've gone to they can be equal, they cannot be greater than, but we should supply an example where they can be less than, and I think that's sufficient for this inequality on the right. Is lim... You're right, I didn't really justify that. It makes sense, but yeah, I didn't say why. There's just regular limits. Yeah. So that might be a way to cut to the chase. I don't know. I don't know if going down like if actually naming and exploring a little bit a different subsequence. I feel like that's helpful. I don't know. That's true. Um, plus b sub n. No, wrong key. I'm pressing so many wrong keys right now. Okay. Is strictly and consider the final inequality in the question proven. Suppose a sub n equals, here we just take a real simple example, -1 to the n, and b sub n equals -1 to the n plus 1. This is like, they're basically like waves on different phases, and we're getting destructive interference here. So begin equation. So many lim sups. Can I do part of this on a new line if I do enter? -1 plus -1. Wait, +1 plus +1. Ah. Equals 2. How does that look if I put the line breaks in there? I feel like it's going to ignore my line breaks, right? Yeah. Yeah, that's not the worst thing in the world, right? Get rid of the parentheses too. It looks stupid. Equals 2. Comma, but slash begin equation I need these combined now. Plus b sub n equals I'm going to cut, I'm not going to show the algebra. I'm just going to show the result of the algebra, which is 1 minus 1 equals 0. Ooh. Where's the part where I... Okay. Let's, we can take this part here and just change the sign. LEQ. Okay. Solve your problem from yesterday? What? Was it 2 plus 4, or did you mean something else? Oh, parts per million? I thought we got the answer. You multiply by 10,000, right? By 10 to the 6? I don't think you do that. You do? Okay. Well, oh, well, it depends what you're multiplying. Okay, that's fair. If you have the percentage as a decimal, then you do multiply it by a million. I was thinking of just keeping it as a percent multiplied by 10,000. It's all the same, Central. So I was thinking if you go directly from this 2.5 and multiply it by 10,000, you do get 25,000. But technically, you should convert the percent to a decimal and multiply by a million. And you get the same thing. I see that Airvon posted a question in the Discord. Yeah, I don't know if it's really different this PQ, but I don't know. Parts per 100. 0.025 is parts per 100? I think the 0.025 is parts per 1? I thought the percent is parts per 100. I don't know, dude. I'm still weirded out that you multiply and not divide, to be honest. 250 ppm? Okay. I believe you. Value an appropriate limit to determine whether the graph... Ooh. It's a horizontal asymptote on the right side. Give the equation of the asymptote. This is some, gotta do a logarithm limit here, right? Let's see if Airvon is watching the stream. You're heading to bed, but saw you live. All right. Well, thanks for saying hi, Central, and also bye. All right, so guys, let's go over to the whiteboard to do this one out. Should we? I should do it without graphing, but I'm gonna graph it. Just want to know what to expect. Was it over x squared, I think it was? Yeah. To the x. Ooh. It's just known to be e? Oh, you could convert it to e. You're right. No, you just split up the fraction to be 1 minus 1 over x. Yeah, okay, proving it is kind of painful. Yeah, you have to do the binomial theorem. E to the negative 1? Oh, is it plus or minus? You're right. Limit definition of e. It's a plus. So yeah, we would have a e to the negative 1. Wait. But for positive infinity, it still goes to e, not 1 over e. Why is that? Wait, no, that's 1 over e. Never mind. Oh, you know what? I just remember when I was reading this book last night, it got one of the digits of e wrong. Where is it? A math textbook got one of the digits of E wrong, and I feel like that's... Yeah, okay. Digits of E. It said this 4 right there was a 5, and they were not rounding. They had a ... And I feel like that's just unforgivable. But anyway. Incorrect rounding is a sin. I mean, I feel like you don't round if you have the ... right? If you were rounding, then 5 would be the right rounding, I guess, depending on how you want to do 5s. Okay, so actually, I don't think I even need to go to the board for this one, now that we, no, SPQ found that. So I want to type a response to the person because I don't think they're watching the stream. Data's contradicts rounding, yeah. Was referring to underscore E underscore? What is that? Christian FR, thanks for the follow. NVM, okay. Is that like floor E or something? I guess even then that wouldn't apply though. Busted our LaTeX skills. Is equal to, let's write out each step here just to make it a bit more clear what's happening. X over x squared equals, wait, that one needs to be squared. 1 minus slash frac 1 over x. So it becomes slash lim underscore x slash 2 slash infinity of 1 minus slash frac 1 over x to the x. This would take a lot of work to prove, but it's usually good enough in a it's usually good enough in a calculus class to just say this is equal to e to the -1. Great catch there at SPQ. Okay. Nice little problem there. Okay, where was I in this? I did not do my parentheses right in the previous limit. Need an extra parentheses there. Okay. All right, so now what? We need to get rid of that. We can get rid of that. Now we have to deal with the rest of these inequalities. I'm considering this last inequality here dealt with. So SVQ earlier put in that we can probably use a property of infimums and supremums to do this limit. And do these transfer over like 1-to-1? Because the thing I struggle with in a sequence is you can have terms of the sequence above the limit superior, because the limit superior is just what it converges to. So you can converge to that from above or alternate or whatever you want. So I feel like it's not, and the supremum of the set is your maximum, your least upper bound anyway. So no elements of that set go over the supremum. So I wonder if that causes potential issues. Yeah, I'm now uncomfortable with using, I guess, like supremum and infimum properties with this without some kind of justification. A sub n monotonically decreases with n. Monotonically non-increases? You don't really, about today, I mean, like, well, you could go up above and below your limit superior and converge to it. Are you saying that can't be the case for a limit superior? I don't see why not. Oh, unless that would exclude the possibility of any other subsequence existing. No, I feel like that wouldn't. Yeah. Oh, yes. Yeah. The entire sequence. So I feel like it's not necessarily a straight 1-to-1 supremum and infimum properties transfer over to limit superior and limit inferior. I feel like this still shouldn't be that hard to prove, though. We just need to figure out the phrasing for the middle inequality. And really, the left inequality should just be another application of the first proof that we just wrote. So I might phone that one in. Well, I guess the inequality is kind of reverse directions, isn't it? It might not be the exact same. Limit is still limit. Oh yeah, I mean, we could consider a sub n b sub n as or a sub n plus b sub n as one sequence for the sake of this inequality, which might simplify things. Is a specific subsequence that I don't recall if it has a name or not. The idea is to take b sub n as the supremum of all a sub k with k greater than or equal to n. What if you're approaching your supremum from above, though? That's where I struggle with the supremum of a set versus the limit superior of a sequence. Limit is linear, and that's all we need. The limit of supremums of certain sets. I guess so. If you're dividing up your infinite series into an infinite number of finite sets, and you're taking the supremums of each of those sets, I guess in theory, yeah. Or you're just taking the tail end of the entire series, which doesn't make, well, no, I don't know how that, I don't know what issues that fixes, that subsequence. All a sub k such that k is greater than or equal to n. Construct a sequence of those dudes, of these dudes. Oh. Huh. I guess I see what you're saying. We start with the beginning of the sequence, take the supremum, step one forward, take the entire rest of the sequence from 2 on, take the supremum, go from 3 on, take the supremum, and all of those supremums should converge to the actual limit supremum, limit superior. That's the subsequence you were talking about. Okay. Huh. I wonder if that would be well placed earlier on in the proof. It maybe simplifies some of what I just wrote, but I think I'm going to ignore that and just push forward. Does it have a special name? I'm not aware of it, if there is one. It's not like I'm turning this paper into anyone. I'm just typing this out for fun. Limit inferior. 1 minus 1 over n approaches 1 from below. Wait, so how does this help us again? So there's this relationship here that, you know, this subsequence that always starts one after the last subsequence, those two primums converge to the limit superior. Does that let us use supremum and infimum properties, though? I guess you can find a subsequence later on enough that it does. And not be a subsequence of a sub n? Really? That's kind of implied by it being a limit point, that it's a subsequence, right? Okay, so I think I've understood the concept that you two have talked about. Let me just, I guess, reread what you two were saying. We're trying to show that they're linear and you can switch them. Oh, okay. It's not a subsequence of a sub n. Okay. Oh, I see. It'll still I see. Okay, okay. That makes sense. Okay, so how can we how can we marry the ideas of limit superior and supremum enough for us to use supremum and infimum properties? Because I feel like this isn't, like, lim inf isn't limit of infimum of a. Like, lim inf is one operator, I feel like. Verify power to both computers hooked into the 230-volt mains through battery backup. Oh, yeah, I didn't even think about that. I guess the power supplies, do those take care of different voltages? Or I guess you might need a different power supply. Defined as the actual limit of imps. Really? Okay, well, I mean, I guess that's true. They should be the same thing. Both power supplies are newer and are switching. Oh, okay. Yeah, that'll be scary when you plug in and first turn it on. Okay, I think I'm on board with what you're saying. Both 110 and 230 and 60 hertz and 50 hertz standards. Okay. Oh, 1 second. Airborne just asked in the Discord how we got e to the -1. Let me find a webpage to link to them. Alright, how hideous this notation looks. You gotta do what you gotta do. Okay, this is the thing that websites never seem to write down, which is what happens if you have like I want this. Would the Wikipedia page have it? I want that, but with A and B. I can just rewrite it in LaTeX, I guess. Okay, I'm gonna write it in LaTeX. Oops. 1 plus a to the bx equals e to the ab. Okay. Okay. Saying my dad's computer died slow due to not accepting unreliable balance 50 Hz standard in the Caribbean. Really? That's. I guess it makes sense that the computer could die a slow death like that, but that sucks. Are we doing math or English with some math? And all the dollar signs. It's basically just an English class right now. I'm mostly debating for like phrasing. Engaging in arts, boundary between the art of mathematics and language is obscure. Yeah. Do we have any double A's laying around? Oh yeah, I deleted everything that I just wrote. Okay. We now show that there is a relationship between the supremum of subsequences of a sub n and the limit supremum, or limit superior, and its limit superior, which also hold for the infimum and limit inferior. Consider all subsequences of a sub n such that a sub n, sub n sub k is equal to, and then I guess we'll just set builder a sub k for all k greater than or equal to, or all n greater than or equal to, or for all a sub n sub k is going to be greater, SPQ saying greater than or equal to n. Should it be all n greater than k or equal to? W log mathematician's version of Lamau. Seemed like an automatic Willog Lamau. Yeah. Oh yeah, that's right. You have to do the escape character. Otherwise they aren't gonna show up. I'm gonna say all a sub n with n greater than or equal to k. That seems like it makes more sense to me. Are we on a new page? We are. That's a double bar. I don't want that. Oh God. Limit sub a sub n is equal to the limit as n goes to infinity of the supremum of all k such that k is greater than or equal to n. But yeah, okay, a sub k such that, I guess so. Don't escape the bar? Okay. That's why it's doubled? Oh, weird. Okay. Wait, so you're saying a sub k, I'm just gonna trust you on that. With the indices. Okay. The supremums of each of these subsequences will approach. Also, insert white spaces in math mode with slash, comma, slash, semicolon, and such. Oh, really? Okay. I guess, oh yeah, that's helpful here, isn't it? Slash, comma. I mean, will that do actual commas, though? Oh, no, it won't. Okay. Okay, cool. That looks a lot nicer. Some are shorter than the others, but you don't. Oh, okay, that makes sense. Then let's write the equation that SPQ wrote. n/2/infinity a sub n equals /limit n/2/infinity soup. We want just soup. / comma a sub k / comma bar / comma. That's a little tedious to do / comma, but oh well. K / GQ n / comma / bracket. Is this what we want? Oops. Define the command for set builder and ooh. That'd be nice. That's somewhere I don't know enough about how LaTeX works, but it'd be good to like look into. Since and now we can use your idea SPQ with supremum is greater than or equal to infimum. New command and some arguments. Can I remember it? So just steal from the internet. Do we have an issue where we don't know that the overall limit of a sub n converges? If we switch the supremum and the limit, how do we know the limit exists? Because it certainly doesn't have to. Or do we switch it back before anything bad happens? Hey, Lo. This is something I'm doing for fun. The original question is up at the top here. Hopefully it shows up okay. If it is bounded, then the supremum of the limit exists. Right, because we're talking about subsequences? Okay. For convenience, define C sub n, because really A sub n plus B sub n for this middle inequality is completely pointless. Let's just take C sub n equal to their sum so we don't have to write so much. Less than or equal to /lim in or /lim soup n to infinity C sub n. So these aren't normal limits that you may have encountered before. These are limit superior and limit inferiors, which they don't follow normal limit properties in the same way. Yeah, so the entire sequence A sub n and B sub n may not converge at all. They're definitely bounded, but they don't have to converge. You've had them before? Okay, okay. Sorry, because I wasn't sure what your experience with this is. So you're guaranteed to have these limits existing because they're bounded, the limit superior and inferior. But actually proving this inequality is proven to take a lot of work. So far in the proof, I think we've dealt with this last inequality over here. And I think the rest of the proof, like these other two inequalities, are going to be a lot easier if we can show that limit inferior and limit superior are basically infimum and supremum phrased a little bit differently. So I'll keep the PDF scrolled there, and then I'll scroll down over here. Epsilon proof? Could you? I don't know that would work. Okay, so I think we take both of these limits and bring them to limits of soups in limits of imps. Epsilon proof is banned in the New California Republic? It is. Would that be easier? Lim inf. Well, we already have this here. Okay, so observe that lim inf n to infinity c sub n is equal to, and then we want this bad boy, but change soup to inf. Change soup to inf. Slash less than or equal to. Now we do the same thing but with soup. And how does this look? Like, is this just the middle proof done now? Oops. C. Look at me, I can speak Spanish. C. That copy pasted terribly, didn't it? Well, get rid of that. Get rid of that. How does that look? Oh, I need another step between these two though. I need to switch the limit in the soups, and then switch them back quick. I think that seems like what we're doing here at least. /inf/lim n to infinity. Okay, I think that's what I need to fix this supremum part though. /sup/lim n to infinity slash that equals. Oh, cross your fingers. It's too big. Insert escapes freely in math mode. What does that mean? Insert escapes freely in math mode? Can make it easier. Oh, I see. Okay, that does make it so much easier. Okay, when you mean like I could do that. That's why this is making kind of impossible to read here. Okay, thank you. It's still too big for the page, which we need to deal with. How do you do it? I mean, can I do like /new line after? Like, what about like new line? Hey, underscore. No? LaTeX new line. Oh, /. Okay. What? What did I do? // I think I hit backspace on accident. What? Do I need to put it on the one above? No? Can you do it? Oh, in math mode? I don't know. I think it doesn't like, I think I think I've tried /n before. Oh, that's for text. /. Wait, what was that /? What's that /n there for a different reason? Why is that there? I don't know why that /n was there. Did I break anything over here? I think we're good. Okay. So maybe, okay, then let's try that thing. I doubt it'll work still. Oh, it just didn't do anything. It's kind of funny. Okay, I didn't realize that /n was there. Just want to use the triangle. Really? The triangle inequality works? Am I doing it a super hard way? I feel like I'm in too deep to back out of this now, but if there's an easier way, it'd be good to hear about. I could do another begin equation. Oh, that'd be stupid. Slash begin align. Let's try that. Align. Okay, well, can you fix that overfold box? Latex align. LaTeX. Then put the slash slash? Okay. Slash slash. Bam! Nice. Also, I should give out like a million saves, especially to SPQ. But we said Anders helping. I don't remember if anyone else helped. Put the ampersand in places to get things to align. Like for vertical alignment, like if I want that to align with that. Oh, okay. That's not vertical alignment. That's horizontal alignment. I don't want. Well, I'm crazy, but this works. It really is magic. Wait. It made them two separate lines. Oh, who cares? Do it before the first equal sign in the LEQ. Do it before the first equal sign. Like, there? The ampersand? Oh, so it's in. Oh! Okay. Mind blown. Double magic? Yeah. Oh my god. Okay. So my idea here is that I'm just quickly switching. Oh, like I'm not caring if limit as n goes to infinity if this thing converges. I'm just quickly switching back to limit inferior and superior before we have to worry about that. I hope that's okay. To avoid labeling the line, you can put no tag. Okay. I want to put no tag right there, I suppose. Hey, okay. Underscore. Now make some ASCII art with ampersand. That's how you do it, I guess. If you do a line star instead, it removes the numbering. Ooh, okay. That's the no tag. I guess the no tag is better here because I still don't mind this being labeled equation 10. I just don't want it to be 10 and 11. And so I guess this right here is the middle proof. Okay. Natalie Conway, it's good to know. I don't know if I needed to know that, but I guess it's a free country. Okay. So we only have to do this left any. It took longer than I thought it would take, to be honest. Oh my, it's been 3.5 hours? I thought it would be like an hour, like the first hour of the stream. And then I go to algebra, but this, I don't know, so it would take this long. What was said? You know, things. Your daily confession, you know, fair enough. I don't know why you would confess here, but it's over in the YouTube chat if you're really curious, low. But if you start the environment and try to force a tag, nothing happens. Oh, okay. Okay, so this idea that's commented right here, I think is what SPQ put in chat ages ago to show the last part of the proof. Are you planning to do algebra now? The interest is peaked. Yeah, I mean, like I'm bringing the. We should bring this home. To do the last inequality, but I think this should be short, right? And then after that, I'll do algebra. Well, I guess though, what confuses me about that, could you consider only the subsequences that are involved in the limit superior if you do that approach? I guess you could, and then triangle inequality gets you where you want to go. That might be a wow. That you might have just completely owned me. So I'm still comfortable with straight up taking the limit of a sub n and b sub n, but if we take the limit of a sub n sub k or b sub n sub k, whatever like subsequences are involved in the limit superior, I guess that would be a pretty quick way of showing that. Web proofs I've seen are so hard. Yeah, that's true. To be fair, the idea of the proof, I feel like, is like 3 sentences or something. But actually getting there in a formal way is at least 2 pages. Okay, what did this part mean again? So we consider minus a and minus b. We're using the property. Okay. Well, should we say a set S? Because what is negative S? That doesn't really make sense. Like, I want to like generally say the property that we're about to use here. I guess a set of numbers. Real numbers. No, this is stupid. Yeah, I mean, we're really concerned with like how it applies to sequences. For a sequence, a sub n. We're saying that the infimum infimum? I don't know how you pronounce this. Slash inf of a sub n is equal to negative sup of negative a sub n. We're okay to just talk about the infimum and supremum of a sequence. I think this is an okay way of stating it. So I just don't want to get involved in, like, you know, sets are not necessarily of numbers, and if I do it like of R, is that necessarily a sequence? I don't know. This feels like it just kind of cuts out a lot of potential questions if I write it like this. So we kind of have to combine the first part of the proof where we dealt with the limit superiors and the part of the proof we just did relating supremums to infimums. Oh, I don't know how to read that. That looks like Norwegian or something. A diacritical mark used in IPA consisting of two triangles and marking the preceding phoneme as long. Yeah, I don't see the two triangles either. Infimum. It just, I always want to say infimum because it sounds like infinity, I guess. Accent on the I, yeah. So we start with the limit superiors. They're right there. Take a gamble, compile. Okay, good. Minus a sub n and minus b sub n. Is it limits superior and supremums? Limits inferior and infimums. Okay, so we've gone to this part, and then SPQ was saying if and only if we're factoring the negative out. Weird M. Voiced labiodental nasal sound? Bilabial nasal M? The lower lip touches the upper teeth? Infimum. Oh my god, they do! Infimum. What the? Infimum. That's so, now that's all I'm gonna be able to note, or infimum. Ugh. That's so weird. Who figured that out? All I can think about is whether my lower lip are touching my upper teeth now. Wait. Oh, I haven't recompiled, that's why. Yeah. Shut up. This looks kind of ugly with just the minus signs. I'll just do parentheses. Okay, now let's copy this. Is equal to minus lim_inf. Why did I do curly braces? What am I doing? Oh wait, why do these get combined into one? I guess because by limit properties, we're combining them into one limit. That I glazed over, that I think we'll glaze over because we already showed it in painful detail up here. I think you saw the last two. I sure did. Thank you. Underscore. This entire thing is not easy to keep track of. Okay, so we need to chain a bunch more things here. We're probably gonna have to do big in a line here. Wait. That's what we were talking about with the subsequences that start progressively one more. Well, no, we need to compare like the infimum to the supremum so we can use that like property that you said. Like I think these two need to go together. Limit n to infinity is just a real number. Oh. Well. Wait. No, this is a set of subsequences. That we're taking all the supremums and infimums on. I could probably be clearer, but yeah. I guess it's a collection of sets. What's happening in this? As are they everyone's limit points? Yeah. I guess this probably isn't really a good way to state it, what's actually happening. Yeah. Like that would need some more justification if maybe if I cared more. or it needs some more statement of what's actually happening there, because it's actually the idea of a bunch of supremums being taken. It's like the limit of the supremums. So it's different from the limit superior. Ugh, I don't know. I'm getting a little bit done with this now. So I'm currently on this part. And using limit properties, you can distribute the minus sign in. Why do we just get to get rid of... Shouldn't there be minus signs in each of these? Oh wait, I should actually be slightly intelligent about how I'm formatting this code. Hey Viv, it not only has it been LaTeX, it's been a lot of LaTeX. This is an obscene amount of LaTeX that's been happening in this stream. Also, you multiply both sides of the inequality by -1 to arrive at the desired form. I'm mistyping this then. I should maybe say implies with this inequality stuff. Or what am I even saying? I'm taking this and saying, oh, wait. What did I do? Ugh. Yeah, I was trying to translate into, I guess, some other form. I definitely lost the thread of what I was, whatever it was I was thinking. I don't even know. Stop. Okay, we'll make that work. Get rid of that equal sign. Yeah, I was just trying to translate the exact thing that you did, and for whatever reason, get rid of the if in only ifs, but that's a little bit too messy. Hey, Ronnie, over on YouTube, how's it going? Just gonna copy down what you put, character for character. I'm doing good too. Thanks for asking. Just working my way through this proof that's been way harder than I thought it'd be, to be honest. I'm getting there though. 2 implies. Yeah. No, I was thinking like not use arrows at all, but meh. So yeah, we're taking this last implication and multiplying through by -1. Wait, I needed to get an inequality sign in here. There shouldn't be an equality sign. LEQ. That should become GQ. Oh, unless we switch the order. I'm gonna say GEQ though. And keep the order the same. Okay. You know, even that alignment's fine. $10. Here I was thinking that we could just argue that sum of the smallest is less than or equal to the smallest sum is less than or equal to the largest sum is less than the sum of the largest. Naive argument. Yeah, I guess it's the subtleties. Does slash box work? No. I'm done with this thing now. Oh my god. I thought this would be much I thought it would be a much easier task, and I guess it is if you use Lowe's idea and don't go off the deep end like I have. I guess like what Lowe said is a much more succinct way of saying more or less what I'm saying. To pursue much analysis. All right, I think I'm calling it quits on this proof. Freaking LaTeX, man. Okay. Yeah, it is interesting. You usually what I would do is I'd figure out like the idea of the proof myself, and then I'd go and look up someone going through the actual proof and read that. Hashtag good enough, exactly. Convinces the target audience. Yeah, SPQ, you are my only you're the only person who I'm targeting with that proof. I don't want anyone else to understand it, which means that I'm good. For example is not proof. I disagree. For example is the best proof. Well, was I on chapter 2 or chapter 3? I think I was on chapter 3. Yeah. I should zoom in, right? Proof by analogy is the best kind of proof. Okay, yeah, I think we just did 17. Let me look at Penn Center's Discord and see which other ones he was suggesting. Oh. Okay, well, I just opened up Penn's Discord, and I did see an announcement from Zach. I'll just show it on my screen. So if anyone's interested, Friday, I mean, this is showing it in my time, but this Friday at 6 p.m. Pacific time, Zach will be on Dr. Gold's channel as part of an AMA, I believe the Golden Hour like podcast, and so people can submit questions and all that good stuff. So just give a little shout out to that if you want to hear about. I think they're going to be talking about like grad school and whether it's a good idea. So if you're interested in that to have a discussion, you should check it out. And if you're in like a European time zone or something, it's hard to do the conversion. It'll be in an hour from now on Friday. Oh wait, Friday's tomorrow, isn't it? Okay. In 25 hours, that's when it's going to happen. Okay. You once read a give no fucks proof that began without loss of generality, let n equals 10 and k equals 7. I love it. Favorite example of the genre? Yeah. All right, so Benzo is suggesting 18, 19 through 21. All right, so just keep going down the list. I haven't drunk water in a minute. I should do that. Ah, okay. All right, so for 18, this one's easy. If a to the 6 equals e, then the order of a is 1 if it's the identity, 2 because a squared is e and e cubed is e. It could be 3 because a cubed is e and e squared is e. Or it could be 6 because a to the 6 equals e. Suppose the sphere is a rectangular box and there's no friction. Approximate the cows as spheres. Okay, so for 19, if A is a group element and A has infinite order, prove that A to the m equals A to the n when m is not equal to n. So this makes, to me, this makes perfect intuitive sense, where if A has infinite order, it's just like shooting off infinitely in one direction. So the only time that two powers of A are equal is if they're the same power. It doesn't cycle around like modular arithmetic or something. The scarcity of fucks given is admirable. And it feels like 19 kind of built on 18, to be honest. Yeah, that'll be your epitaph. How do we actually phrase this proof for 19? Oh, I think I see it. Yeah. So I was thinking about how a contradiction proof would work. And I think we're gonna say A has infinite order, and for contradiction, assume A to the m equals A to the n when m is not equal to n. And we're going to get to the stage A to the m minus n equals E, and that violates infinite order. Anders agrees with contradiction as our approach. Okay. Let's write this baby out. Ah! Oh, wow, okay. So it sounds like you agree with what I said, too. Let's actually, like, write it out, though. Ugh. Okay. By way of contradiction, let's pull an enigma here. Assume A to the m equals A to the n when m not equals n. I guess we say there exists an m and an n, such as this is true, but who cares? No, I should really say that. mn. So A to the m equals A to the n means we can multiply by A to the n inverse and get A to the m minus n. Oh, this is actually... Actually, we don't even need to say... It's fine if that's a negative number because inverses have the same order. Yeah, and that okay, I thought this would be more writing, so I want to write it out, but I think it's just like 2 steps. Yeah, I got some whiteboard stuff in my Amazon cart. I just need to actually like order it. New ink. For like my black marker especially. It's been out for a long time. I should throw probably a couple erasers because those things do not last long. But I think it's also in part, like I've written so much on that section of the board that I need to rotate that thing. That's true. And so, oh yeah, I even said that it would build on the last exercise 18. But yeah. But yeah, if it divides m minus n, then it's finite. I guess is the important bit. Bit of white vinegar, slightly wet sponge works. Oh, that probably would work too. I know the spray, I just get lazy. Okay, for any group elements A and B, prove that the order of AB is equal to the order of BA. No, the spray doesn't smell like anything. I guess, yeah, there would be a smell if you use vinegar. So if we have a string of like AB, 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 let's say m many times, equals to a string of BA, 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 n many times, can we do anything to make those match? Or like it says from before, that helps. It just proves it immediately? Would it... Is it that an element and its inverse have the same order? Vinegar gives you an excuse to cry in front of the whiteboard without it being due to math? Oh god. Too real. Not quite, but close. Can we do with that? I assume we use exercise 13 here. How do we do that? We want to set up the order of something AB, something inverse, to get the order of AB. And hopefully, or how would we, like... There's some clever setup that'll get you what you want from that, I guess. Maybe let's just try playing around with it and see if we can get it. How's the blue marker doing? What the heck am I writing? Oh. Do we have to name an X such that this results in AB? Or BA, rather? So really what we want to do, we want to solve the equation equals BA, and then whatever we get for X is our answer. And X equals B? So then B inverse equals AB, which means that BA equals, oh, okay, that's neat. Good hint there, SPQ. We'll have to conjugate AB by B or A inverse. Oh, I guess A inverse would work too, yeah. All right, let's get 21. If A is an element of a group G, then the order of A is less than or equal to the order of G. Okay. Conjugation in groups, normal subgroups and quotient groups, examples and applications. What is that? The order of A is less than or equal to the order of G. So this is a weird, the order of G is the number of elements in G. So you have to prepare to become a teacher. Oh, okay. There were 70 of those? That's, oh, you're saying how insane the test was. So like, you're saying like teacher, but like, are you gonna be a teacher at like a university? If you're doing stuff that's that hard then? So I guess off the bat, we can say if G is infinite, then the order of A, it's certainly less than or equal to infinity. I hope that's not too much of a stretch. It's the high difficulty one? Okay. But if G is finite, then what happens? Well, A doesn't possibly have enough powers. A can't have more powers than there are elements in G because it's closed. So it must cycle back at some point. So this feels like I'm going towards another proof by contradiction, where we would assume that the order of A could be greater than the order of G, which would imply that the order of A could be the order of G plus 1, let's say. Wait. But the point was that the order of G plus 1, if that element exists, then you're violating closure. But how do you say that? The cyclic, or the, wait, the cyclic subgroup generated by A, is that what they're called? Or just the subgroup generated by A? The subgroup generated by A, okay. Yeah, it is cyclic if we're talking about finite, I guess. Infinite? Wait, you can have an infinite cyclic subgroup? How does that work? If it's infinite, how does it cycle? Or if it's too complicated and I'll find out later, that's okay too, but it is unique. Huh. Okay. Z is the only infinite cyclic group? I don't understand how Z cycles, I guess, but maybe I can just accept it. I don't know. Cyclic assumes finite. Really? Okay. A single generator? Okay, I think cyclic subgroups are the next one. How do they define cyclic? Oh. It has a single generator. They defined it in the last chapter, I guess. Where did it say cyclic? It's not like that important, but okay, fine. The single generator thing works for me, but anyway. Monogynous. I never heard of monogynous. Monogynous. Asexual or oh, it's like a single generator would be asexual? Having a single differential coefficient considered as a rule of generation. That's kind of funny if that's why they chose the word monogynous in math. Anyway. Get me out of hope relief as well. Okay. We don't call Z cyclic, really. Okay, so as you said earlier about the order of A being equal to the order of the subgroup generated by A, that makes sense when I actually think about it. Because if A to the 6th equals E, then your subgroup is E, A squared, A cubed, A to the 4th, A to the 5th, and that's 6 elements. I don't know how you necessarily prove that, but I don't know how you prove the actual question either. prove those things are all different, which I assume would be implied by the order of A. And then a to the n equals a to the n plus the order of A for any n in Z. True. If you prove the order of A is equal to the order of the subgroup generated by A, then you know that the order of the subgroup generated by A is less than equal to the order of G. Because oh yeah. Maybe that's so. Oh God. That's basically LaTeX, but in Twitch chat. Yeah, I mean, it does make things less, or if you know LaTeX, I feel like it can be helpful, but of course, if you don't know LaTeX, then, you know, who knows. So what I'm trying to work out is how the things at SPQ I assume the two things SPQ put first there is how we prove the order of A is equal to the order of the subgroup generated by A. And I'm kind of trying to bridge the gap between those two facts and how they actually get us there, but sure, we'll figure it out. We're adults. A is equal to A squared dot 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 A to the A minus 1. We're adults? Yeah, unfortunately. We want to prove that all these elements are different? We can show that there's inverses of each other. How would we show that, like, A squared is not the same as A to the 5th, for example? Like, how does that get, like... I don't know, that's weird. If and only if A to the B inverse equals E? Oh, okay. So... because for any 1 is less than or equal to I comma j, I guess 0. Less than or equal to the order of a minus 1. A to the I is not equal to a to the j, because I'm saying because twice in a row, and that's just the way this proof is going to be. A to the I times a to the j inverse is not equal to e, because I minus j is less than the order of a, and that's just kind of it. Yeah. I assumed I is less than j. Oh. I mean, that doesn't hurt. So we don't have to worry about negative powers. It might not be like I kind of, I guess, like in last time I assumed it wouldn't be necessary because inverses have the same order, but maybe it doesn't look like that. I don't know. It doesn't hurt. The slash in LaTeX, it just, you put it before a symbol that you can't type on the keyboard. So if you want to do like not equals, since you don't have a key on the keyboard, you do slash not equals. So you just have to know that any Q goes with not equals. But yeah, the slash just, it always precedes like a symbol of some sort like that. Okay, so what was like step 2 that SPQ laid out for us here? Meant not? Oh no! The default example? Yeah, I mean, isn't I just saw you say an EQ? And you're saying, and then prove a to the n is equal to a to the n plus the order of a, which is, I already see how we do that. Plus a. Well, actually, let's work from one end and build to the other. It'll be, I mean, it looks a little bit cleaner if we do it like this, or it's a bit more natural to do it like this. A to the order of a, which equals a to the n times e, which equals a to the n. That part's pretty simple. Now, how do these two facts... You don't know what the next string of letters means? Yeah. Well, I mean, when I was doing the LaTeX stuff, I was constantly Googling how you make the... Like, for a symbol, what's your random string of characters? So we want now to get to the order of A is equal to the order of the subgroup generated by A. We've shown the subgroup has distinct elements. We've shown that you can add the order of A and not change anything. do you have to take... Do you take each element of the subgroup generated by A and add the order of A to it and show that it's you just get back to the same element so there's nothing else in the group? You can represent it as n equals q times the order of A plus R with R being okay. So let's get another index. Presented by A to the I times N, or I plus N order of A, or an integer N? Is that what we want? I think so. It's basically what SPQ was saying. A to the I plus N order of A is equal to A to the I times A to the N order of A, which equals A to the I, A to the order of A to the power of N, which is A to the I, it's IE, which is just A to the I. Therefore, the subgroup generated by A, actually, well, we're not at the end of the proof yet. It's coming close to the end of the proof. Subgroup generated by A contains exactly the order of A elements. So the order of A is equal to the order of the subgroup generated by A. And sign since now, how do we say subgroup? I feel like the book was saying less than or equal to. The order of A is less than or equal to the order of G. Or were they doing... No, I think they were doing less than or equal to for the actual group. For subsets, they were definitely doing like the regular subset. Or sorry, for sets, they're definitely doing subsets, but I feel like for groups, they were doing less than or equal to. Or I guess for subgroups, they would use the inequalities. Okay. Awesome. Farming those saves. So we just did 21, and let's see what else Penn Center was saying. Oh, 22 and 23, and then we skipped 24. Okay. So 22 and 23. Show that U of 14 is equal to the subgroup generated by 3 is equal to the subgroup generated by 5, and U14 is cyclic. Is U14 equal to 11? Okay. I mean, this is going to be just like computations then, but it's probably worth it for me to do it because I'm new to this. And it'll help me wrap my head around it. All right. So let's first list out U14. It'll be everything that is relatively prime to 14. 1 and 1. 3, 5, 9, 11, 13. And we need to list out the subgroup generated by 3. So let's just go through our powers of 3. Mod 14. 3, 9, 27 becomes 13. 13 is also -1 mod 14. So we also have -3 mod 14, which is 11. 11 is -3 mod 14. So -9 mod 14 is +5. And then we'll be at the end here because 3 times 5 is 15, which is 1 mod 14. So look at that. We just get the same group over again. And then we also had to look at what, 5 or 9? 5. So we start with 5. 25 becomes 11. 11 is the same as -3, so -15 becomes 13. 13 is the same as -1, so -5 becomes 9. 45 becomes 3. And then we get 3 times 5 is 15. Okay. So we do indeed get the entire group back out, which means that 3 and 5 generators for the group is U. And then they also want us to look at 11 though. All right, so we definitely get 11. 11 is the same as -3, so +9. So we do get to 9. -3 times 9 is -27, which is 1 mod 14. And then we just cycle back because we hit 1 too early there. Okay. Then let's look at 23. Show that u sub 20 is not equal to k for any k in u sub 20, or in u of 20. This seems kind of tedious. Do I really have to get the cyclic group generated by every single k? Because U20 is what? 1, 3, 7, 9, 11, 13, 17, and 19. I'm not doing all that work. It might not be that bad. Some of them are going to be short, I guess, but like, doesn't take as long. All right, let's do it. I guess like for 19, there's only going to be 19 and 1. One, 3, 7, 9, 11, 13, 17, 19. Okay. 3 is going to be 3, 9, 7, 1. We hit 1, so we're done. 7 is going to be 7. Oh, I will say like 14. That makes no sense. 49 is 9. No, wait, never mind. 63 is 3. Okay. Well, these two are clearly related, I guess. 9 and 1. Oh, 11 and 1. That's 121, right? I did a curly brace there, and it's annoying me. Goodbye, eraser. 9. Negative 7 times 9 is negative 63 is 17. Negative 3 times negative 7 is negative 21 is 19. Negative 1 times negative 7 is positive 7. Negative 7 times 7. This feels wrong. Negative 7 times positive 7 is negative 49. It's 11. I guess we're okay. I don't know. 11 times 13. 143. It's 3. That's 39? Which is 19. No, I did something wrong. Can show that 3, 7, and 13 have order 4, then it cannot be integers mod 8, which only has 2 elements of order 4, hence it is not cyclic. Well, it's using an isomorphism, I guess, or that I haven't learned, or is there something that I'm missing? 13 squared is 169, 20 goes into 160, so 9 I stand by. 13 times 9 is the same as negative 7 times 9 is negative 63, which you go to 80, so you get 17. 17 is the same as negative 3 times negative 7 is positive 21. There we go, that's where I messed up. 17. Negative 3 times negative 3 is 9. 9 times negative 3 is negative 27 is positive 13. Negative 3 times negative 7 is positive 21. There we go. Then 19 should be self-inverse. Okay. No fair reading ahead. Yeah. I think the point of the question was, I assume the point of the question was to do that manual calculation, and then we'll eventually have the tools to just look at it and see, or only do a couple of calculations. All right, so we're skipping 24 and going straight to 25. What is 24? We don't have to follow what Penn Center said. We can be rebels. And is an even positive integer, and H is a subgroup of Zn. Prove that either every member of H is even, or exactly half the members of H is even, or even. What? Oh, okay, so if everything is even, you have a power of 2. If half of them are even, you have a not power of 2. Is that it? N is an even positive integer, and H is a subgroup of Z sub n. So it's, you can't, okay, this is addition mod n. So the inverses are negative numbers. So it's not as simple as saying half our things have to be inverses, and odds aren't like an inverse here. Or wait, addition mod n. I'm underthinking this, right? I'm underthinking this. It might have to do with powers of 2 for everything being even, but for whatever reason I was thinking, I don't think is right. So I was thinking of multiplication mod n, but this is addition mod n. Ooh. Oh. Well, if everything needs an inverse, then either everything is even because the other half, because you maybe only took even numbers, so the other half is also, or, you know, because the inverse of an even number is also even in addition, and the inverse of an odd number is also odd. Okay, so we do rely on inverses here. If n is an even positive integer, am I taking any class at the moment? No. I've got things that I would like to self-study, but I'm not a student right now. It's a goal of mine to go back to grad school, but hey, Govan. In the same boat? Oh, nice. Yeah, so when Penn Center and OB do those differential equations and complex variables classes, I definitely would like to participate. I was not sure it's not like too much of a time commitment if they're both happening at the same time, but other than that, it's also a great way to save some money. Well, yeah, it's not a great way to get proof though. Go on. Yeah, I'm taking questions. If you want, you can type it out there in chat or put it in my Discord or any of the other Discords and tell me where you post it. Hey, Jed. Oh, I see you put it in general there. Oh gosh, we got some linear algebra. Ew. See if we can figure it out. It's a definition? Okay. Hey, Enigma, we just were, I was going through and doing some chapter 3 stuff that you guys may have already done. So like I'm gonna always be behind in the reading group. I was just looking at 24 that wasn't assigned, but it looked interesting. But Govan just asked a question that I'm looking at now. So this is the definition that we need for the Govan's question. I don't know what the question will be yet though. Oh gosh. I don't know if I'll be able to do this though. This is a little deeper in the linear algebra than I remember offhand, but we can see if we can get it done. Last one was tough. It relies on the Schrader-Bernstein theorem, like the 24? Or are you talking about 23? You're doing number 1 here, or what? It's question 1? Okay. 24 does? Oh, wow, okay. Let T map R2 to R2 be linear transformation defined by this. Okay. Oh, wait, this is just a normal linear transformation. This isn't anything that fancy. Okay. That's what was worrying me at first when I saw this, that it was some special type of linear transformation. Let U be 1, 1 and U2 be 1, negative 1 and alpha equal... Okay, so U1 and U2 are the basis vectors for V. Okay. No, I haven't surfed to Ben. Someone changed map? I surfed like a day or 2 ago. Probably 2 days ago. That was the last time I surfed though. Oh, does that mean someone else surfed in the meantime? And then the W vectors are the basis for beta. Oh, good. Find the relative matrix for T for alpha to beta. Okay. Mystery surfer. Oh, you don't have like logs if you really wanted to know? Oh, interesting. Not available? Wow. It's kind of weird. If you're paying for a server, but I don't know how that works. Okay, so we have... Hey, Mangoes, how's it going? I think that vision is an example that's more complicated, and the book doesn't ever apply it to a simple linear transformation, so you're struggling to apply it. Yeah, I'm struggling to apply it too. Find the relative matrix. Happy to work. Glad to have you here. Yeah, so we have the bases of two spaces. Oh god, I'm going to use the wrong term here, but we have 2 basis vectors for each of these spaces. How do we find the matrix that maps from one to the other? Did they remove prime sub? Prime sub is still a thing, as far as I know. Linear algebra is non-commutative algebra with too many indices. Yeah, linear algebra is not my strong suit. This one, I think I can do it. I just need to remember how the heck this stuff works. This example, they show such a complicated example, Govan, I agree. Find transformation Like, do we not just take one of the bases like wholesale? Oh no, you don't necessarily do that. From one basis to another. This is 3 dimensions. If you write T as a standard basis, and then you have the change of basis in the domain and codomain. I don't know what that means. Sorry. I'm not smart enough. I assume we're gonna have to like put these both into 2x2 matrices and do one of them times the inverse of the other at some point. Or that's what and I assume that's what your statement is going to end up being. I'm just confused on how to get there, I guess. Okay, you'd be going, if T is the standard basis. Do you feel like you remember doing this homework problem? I probably have done this exact thing before. If you want to transform from the standard basis into, let's say, U, you just take U as a 2x2 matrix, don't you? So it'll be 1, 1, 1, negative 1 times xy. Well, is it equal to the new 2x2? No, ooh, E. Let me turn the light on, it's getting dark in here. Oh wait, no, actually I was kind of misunderstanding what the problem even is here. It's not as simple as I was thinking. Find the relative matrix where the ith column is T of U sub I sub beta. Friend, find relative matrix. The basis, sure. Hey, Anders. Are you good with linear algebra? Yes? Okay. No pressure if you can't, but this is something that Govan's asking about number 1. I thought this was something that I knew, but I'm quickly realizing that if I did learn this, I don't remember it. Posted an image might be helpful. Got the formula from office hours. Okay. I'll let the question be up there. I'm looking at this off to the side, what you just posted, Govan. You're unfamiliar with the notation? Oh, dang. Okay, no worries. Can you show the example? I guess I was just on this one. Alpha and beta are basis vectors, which I guess you could write them as a matrix. I see. This is what the person posted initially, though. They're saying it's not right. Whatever's up here. Suppose that it's A, C, B, D means that W1 equals more complicated one from the notes. Oh, that one. In my Discord, Anders, in the general chat. The formula, that doesn't make that much sense to me either. I'm going to be honest. It might help, and I'm just not, and I'm like just too rusty on linear algebra. I'm just not easily able to figure it out right now. You get it now? Oh gosh. If you're able to explain it, or if you don't have my voice, then that would help. Like, well, let me know. But if you're able to like at least give us a hint or something, that'd be helpful. Or SPQ was saying something as well, but I was having a hard time understanding the setup, I guess. A, B, C, D, written by rows? Sure? Okay. Or I guess like, sure, you want to talk, or what's up? Or if you need a minute to get like set up, it's no worries. Plug in the tablet. Oh, cool. Thank you. All right, go on. We'll be able to give you an answer, hopefully. No worries. Yeah, this example is kind of crazy. Also, welcome in Shame Pearl. Made myself with a notation though. It's better than anything I could come up with, at least. Whatever you do.
Hey, Don.
Hey, thanks for doing this. Oh, sorry, what?
Can you hear me well?
Yeah. Can you hear me okay too?
Yeah. Great.
Awesome. So I'm going to show my Discord. And I guess let me know once you're able to screen share. Or else I will see it. Okay. Bringing it up. Oh shit, you know, I can make it bigger. Come over here.
This image is relevant. I'm going to take a screenshot for that. Here. Okay. So do you understand what this equality means?
Uh, not exactly. I guess are we going to apply this transformation to each of the basis vectors U?
Okay. Let's do a review. Each vector space, in this case, we are working with R2, admits infinitely many bases, right? We usually
Right.
take the canonical basis, but we can take others. So
Okay.
when we choose any base, one for the domain, one for the codomain, we can characterize the linear transformation by a single matrix.
Right.
We're going to represent the linear transformation by a matrix, but this implies the election of two bases, one in each place. Okay.
Right.
Okay. So this is where alpha and beta are. That's the role that alpha and beta are playing here.
Yeah, we're going
So
from the basis alpha to the basis beta.
yeah,
Okay.
this R2 is being think as a basis alpha,
Okay.
right?
Yeah.
And the other one, it's from beta. And we have this linear transformation.
Okay.
So once we choose both bases, the matrix representation of the linear transformation is by definition the transform vectors of the basis in alpha, right? These U1, UN are coming from alpha. Okay.
Yeah.
And the columns, the numbers in the columns represent the linear combination with respect to the basis beta. So for example, if we have that, let's say U1, which is an element of the basis alpha, we can think where this U1 goes in R2. In this case, U1 is this vector, right?
Right.
And applying the definition of the T, we get 3 times 1 plus 2 times 1 and 1 minus 1, which is 5, 0. Okay.
Okay. Yeah, I was getting confused. Where like, if is that T11 like T as a function of 1 1, or is it T times 1 1? I guess it ends up being the same thing though.
This is as a function.
Okay.
T being a linear transformation means that
Oh, of course,
this
as
is
a function. Okay. That makes sense.
Yeah.
So that's the first column of our A to B, or alpha to beta?
Exactly.
Okay.
No,
Or-
sorry. Because this is in the canonical base. We took
Oh.
U1 with respect to to the canonical base. And this definition is also giving us the vectors with respect to the canonical base of R2.
Okay.
So we need to find this vector as a linear combination of the vectors in beta. Let's say this is A times the first vector in beta is W1, which is 1, 0, and B times the second vector, which is 2, 1.
Okay. So we'll get.
Okay. So
Oh, it'll be a
the
little weird.
first
3 and -1. No.
Yeah,
Never mind.
let's take here this matrix has the first column as AB, which comes from this equation.
Okay.
Yeah.
That makes sense.
Similarly, we want to use the U2, the other vector in alpha. What is it? 1 minus 1. Okay. 1 minus 1. By definition of T, we get minus 3. No, sorry. 3 minus 2. And 1 minus 2. We get
Yeah.
1, 2.
And then the same process.
Yeah, E1, and we want to find the linear combination of this vector with respect to the base beta. So let's say it's alpha. No, I don't know.
Oh, yeah. I guess a different constant, but.
Yeah.
Or it's like C and D or R. Yeah.
1, 0 plus S. That looks like a 5. Sorry.
No, you're good.
S. Okay. And solving this equation, we will have the second column, which is RS.
Interesting. Okay. And then that's just the answer.
Mm-hmm. Yeah, we need to solve these two linear systems, and we're done.
Okay. Govan is saying, this was earlier that Govan put it, but do I then input 5, 0 to the matrix W1, W2? Oh, wait, yes, I can solve this. This makes a lot of sense. Okay. If that makes sense to you, Govan, then I'm glad. This is a really nice explanation, Anders. Thank you.
Oh, no worries. You're welcome.
Is there anything else you want to hear about this, Govan, or are you okay with this problem?
Questions about this?
Yeah.
Huh?
Not for me. I just want to make sure that Govan is all good. Although I think Govan is.
Oh. Okay.
Govan's okay with this? Okay. Yeah, thank you for that. Because I was like, I thought the problem was simple, and then I realized it wasn't. So I was like, oh god, I need help.
No worries.
Yeah, thanks. I guess I'll hang on now, but I appreciate it.
Yeah, I will stay in chat.
Okay, sounds good. Okay. Huge save for Anders there. And as well as for SPQ, because you were valiantly trying to help, but I'm just too slow. Sounds good, Govan. Glad that at least other people were able to help it, even though I couldn't. Thanks for the follow, Shame for All. Okay. Okay, so what should we do here? So sure I didn't miss anything during that. All right, so we were thinking about 24 before, so maybe we'll wrap up with working on 24 from the algebra book. And so I felt like I found the idea there, but SPQ was saying something about some theorem. Let's see. Schrader-Bernstein. What's up with that? Bernstein theorem. Salvation is undeserved. Oh, no worries, SPQ. I appreciate even the attempt, because I just be hanging. Contains the idea, it's much more general in our case. Okay. I had the matrix part right in my head, but the vector part tripped me up. Yeah, I was I was doing way too much matrix multiplication, not enough linear combinations. In set theory, Schrader-Bernstein's theorem states that if there exists injective functions f maps a to b and g maps b to a between the sets a and b, then there's this bijective function h that maps a to b. Really? Injective is 1-to-1? Oh, look at this like circuit looking diagram down here. Oh, okay, this like cardinality explanation is really nice. Yeah, because it's 1-to-1. That function, the domain of the function must be at least as big as the codomain. Is it an easy way to solve it with matrix multiplication? Oh, really? So I was trying to figure out, like, I thought there would be some kind of equation you could set up, and then you can, like, isolate. I guess it'd be t in terms of beta. But I was having a hard time getting there. Surprisingly non-trivial as far as you recall. I mean, definitely this proof isn't short. It's equivalent, but easier in the sense that you do just one matrix multiplication to solving two linear systems. Oh, okay. I mean, at least in the example that, or in the problem that we had, the systems were pretty simple. I was trying to do them mentally, I kept messing up, and then I realized later that it was way easier than I thought. But yeah, I guess if you have a bigger system, it might be like more practical to do the matrix multiplication way. I guess we don't need to worry too much about the actual proof here. Hello to GCG on YouTube. What's the question? You can type it out there, or you can put it in my Discord if it's easier. So suppose solution U explains if we go by definition, which is the second image. Oh, okay. Yeah, that's probably a better way to explain it then, if that's the way that Gabon was likely intended to solve it by. Domain and range, you don't know what it is. Are you maybe like a pre-calc or an algebra class? Because I could definitely like show some examples of domain and range, like with a parabola or something. You're in algebra? Okay. Oh, so I'm sorry, you don't, I'm sorry, I thought you were saying you don't know what the question is, but your question is that you don't know what domain and range is. So I'm happy to explain what the domain and range are to you. Okay. Do you have both chats in the same window? Oh, in the box up there? No. I would love to, but Twitch specifically does not allow that. unfortunately. Okay, so if you have a specific function you want to see me talk about, let me know. But if not, I'm just going to I'm going to make up some examples here. Let me erase the board and I'll check chat after I do that. So yeah, I have the chat up in the box, at least so YouTube can see the Twitch chat. But I would be breaking Twitch's terms of service if I showed the YouTube chat to Twitch, unfortunately. So you'd have to, if you want to see, you'd have to open up 2 windows. Which I know is a pain. Okay, I don't see anything new in chat, so I'm just going to make up some examples to talk about domain and range. Okay. So if you're in an algebra class, I'm going to give like the basic, I'm going to give the next which domain and range geared towards an algebra class, I guess. So the domain, simply put, is what you're allowed, I'll put in quotes, oh god. So plug in for x. In the range, and I'll say more about what this means later. The range is everything you can possibly get for y. It's what like y values are possible to get to, I guess, for all your values of x. So just make sure there's nothing new in chat or the Discord, which looks like we're all good. Okay. So if you have, I'll start off with something, you know, like maybe like one of the simplest examples is y equals x. Here, you know, maybe this isn't the best thing to start off with. I want to explain a bit more about like the domain, what you're allowed to plug in for x. A situation where you're not allowed to plug something in is if it would cause like dividing by 0. So if you have like y equals 1 divided by x, you can't allow x equals 0 because dividing by 0 breaks the rules of math. So here you'd say there's a lot of different notations for the domain or different ways to represent it. This could be considered your domain even, x not equal to 0. But I think I more commonly see like x greater than 0 and x less than 0. Like you can represent it with inequalities here, or you can represent it with interval notation, which I guess if you're in America, the way that I'm used to writing it would be like negative infinity comma 0 union 0 comma infinity. Other countries have different conventions for the notation a little bit. But there's, depending on the class, there's a bunch of different ways to kind of express the numbers that are valid for x, which is anything except for 0 is kind of the point here. So that's an example when you're not allowed to plug something in for x. So we're not allowed to plug 0 into the domain. We can take any other number we want and we're not breaking any rules. Another way to represent, actually, before I forget, you might see this like fancy looking R or just like a capital R in bold or something like that. That means all real numbers, so just every single number ever. And I guess you could even write this scenario as every real number minus 0. It's not a literal subtraction, it's called set subtraction, which is maybe, you're probably not going to use this notation, but it also exists. So I hope I'm not confusing you too much. It's just whenever someone just like pops in a chat and asks me about domain and range, I try to cover all my bases with what the different notation could be in your class. So I just don't know. Another scenario, I haven't even talked about range yet, and I'll get to that later. I want to give one more example for the domain. Another scenario we should worry about is like the square root of x. So thinking about square roots, a positive number in a square root is fine. 0 in a square root is fine, but a negative number is bad. Square root of -1, we're just saying is invalid because we're not going to get into imaginary numbers or anything weird like that. So for square root of x, we can't have -x. So we'd put like this idea for the domain into math speak by saying x is greater than or equal to 0, because 0 itself is fine. If we're doing the interval notation, we would say it goes from 0 inclusive, which is square brackets, out to infinity with parentheses. And if you haven't seen this notation, but if I'm showing notation you haven't seen before, just don't worry about it. If you tell me notation you use in your class, I'm happy to only use that, but I'm just trying to be general. If you see doing algebra in earnest, so if you see the linear map. Oh, yeah. I assume when this person says algebra, they mean like a high school level algebra class, not like abstract algebra or linear algebra or the other meanings of algebra, but yeah, that's true, SPQ. Sorry, because if you study math at a higher level, the word algebra becomes very complicated. So when someone says they're studying algebra, it doesn't mean the algebra that we're doing right here. But in this case, I'm assuming that this is what you mean. Okay, so we've given two examples of like figuring out the domain of a function. Are there any other scenarios we should worry about immediately? I guess we can say logarithms if you've learned about those. If you haven't learned about these, don't worry. But if we had log base 2 of x, we can't have negative numbers and we can't have 0 inside a log. So we'd say that our domain here is x greater than 0, not or equal to, or parentheses for not included, 0, infinity. So these are all domain. I haven't even touched range yet. That's not a B. Let's think about range. So I want to give some different examples for range. These ones are they're going to be a little bit weird for range. So I want to give a more familiar example. So range, let's start off with this. I'll start off with y equals x. So quickly, the domain of this, there's nothing that we can't plug in for x. So we'd say the domain is all real numbers. And I'll just do the fancy R to symbolize that. We can plug in anything for x we want. And you're hopefully familiar with y equals x being a line that looks something like that. And like, x and y. So just from the graph, we can see that y is eventually going to, shoot up to infinity and go down to negative infinity. So this line is going to eventually cover every single y value out to infinity. There's nothing that it won't reach. So we say the range is also going to be everything. So I'll do fancy R. It could also be like minus infinity, comma, infinity in parentheses. I'm not sure how else. There probably is a different way to say it too that I'm not thinking of. But yeah. So now let's look at a different example where we don't reach every number. Let's look at y equals x squared. So for this one, again, we can plug in anything we want for x. So I'm going to, just set an aside. Let's say that our domain is everything. And then when we think about the range, let's actually graph this, because x squared is a parabola. And it's its face is up and the vertex is at 0, 0. So here we have a very different story for our y's. The y's are only above the x-axis here. We can never get a negative y out of this. We can get 0 if we plug 0 in for x, but we can never get a negative number. So here we'd say our range is y is greater than or equal to 0. Always remember to test your like endpoints manually. So like if I think that y is always positive, I'd say y is greater than 0, but that should trigger me to say, oh shoot, let's check if 0 itself and see if that's included or not. That could be a way to like get tricked. In general, I would say that the best thing you can do to figure out range is to graph it. And you don't even need to get an exact graph, you just need to know the general behavior of the function. So like here, I didn't like label any points or anything like that. I didn't plug any actual points in, I just know the shape of it. So I guess that's my quick explanation for what domain and range are. Let me know if you have any specific questions on that. Or any questions at all, I guess. Not seeing anything from you yet, GCG. I'm probably going to wrap the stream up in a second here, so if I don't see anything soon, I am going to cut things off, but if you have something further, I'll stick around for a little bit. That's all you need? Okay, cool. Glad to help. Thank you for the question. So particularly being which you're not allowed to evaluate T. No worries, GCG. If you've heard of twitch.tv, the website, there's actually a whole math community over there of people who stream. If you ever find yourself in need of help in the future, all the people on the list that's about to come up will be able to help you out with questions. So if I'm ever not around looking for math help, those are people who are there. Yeah, I think I'm gonna cut the YouTube stream off here. So be sure to check them out. Awesome. So yeah, I think I'm gonna wrap things up for the day. So GCG, you and anyone else who's here on YouTube, I appreciate you all. I'll be streaming again on Saturday with more math, starting 5.5 hours ago, whatever that is in your time zone. And thanks YouTube for being here.